welcome to the next stream in our little space shooter building thingy. Give it a few minutes for people to slowly start coming in. Let's see how everybody's doing tonight. All right. Oh wow, I can see that it immediately starts playing an ad. I'm actually having a look at what it's doing on my screen for a change. I've never really looked at things that way. Hi SSLX, welcome to the stream. Alrighty. So I hope everybody's doing well tonight. I think I'm gonna trust that this will run, so I'm just gonna close that off. Alright. Cool. All right. So this time I am going to just immediately switch back to actually showing my desktop. I don't really have anything more to add on just on the camera. And last time we forgot, so I'd much rather do that right now. So that should do the trick, I hope. Okie dokie. Still waiting on people to slowly come in. We're going to move this a bit out of the way so that I can see what's happening. There we go. Sweet. All right. So last week we got to the point where we could shoot our rockets, and our rockets had some simple logic that allowed them to home in on the enemy ships that we've got in our scene. And of course, like last time, like every week, I have done a little bit of work off camera. Not that much. I spent about I think 3 or 4 hours extra on it. Unfortunately, I had a bit of a busy week. So yeah, let's quickly go through the changes that I have done. And then we're going to go back on to improving our missile system. I'm also thinking about making our enemies move. Now, I'm not really ready yet to do a full AI for the enemies, but I at least want to get them to a point where they're not sitting still in space, but that they're actually moving around. Cool. All right, so the first change is hopefully immediately visible here on screen. We no longer see our 3D view here, but Godot goes into the 2D view when we open up our project. And the reason for that is that I've moved everything into their own viewports. So by default, when we are building a game in Godot, you render directly to the screen. And of course, with VR, we're actually moving part of that rendering and sending it to the headset, to the HMD. And the thing that you now see on screen, the preview that you see, is just a dump of, if I'm not mistaken, the left eye as it is, so that it fits on screen. And one of the problems that we're having is because in VR we are rendering the image at a fairly large field of view. We are seeing a lot of the peripheral vision in our image, and what's actually in front of us is a tiny part on our preview screen. While if I have the headset on, that center of the view is actually really most of my vision, and the peripheral vision sort of wraps slightly around to the side. So everything looks much bigger, much clearer inside of the headset. And and I really wanted to show that better in the preview on screen as well, so that the preview is more akin to what I'm seeing in the headset. Now, obviously that means that we're missing the peripheral vision in our desktop version, but that is actually kind of the point. That's something that you know, that's why generally speaking games are usually rendered at 60 or 70 degree field of view, because that is the field of view that you have towards your monitor. So yeah, the simple change for that is that our original main scene, so basically what we had in our previous version, is now it's a scene by itself. So if I would run this standalone, I would be back at the game as it originally was, but it's now put into a separate viewport, an HMD viewport. And this HMD viewport will be the viewport that's set up as the AR/VR viewport. So this is the viewport that we render and that we send off to the headset. But nothing else happens by default. If I would only do that, I would just get a black screen on the desktop and I would render to my headset as usual without actually adding anything performance-wise, because the same amount of rendering still happens. It's just, you know, nothing's now output to screen. So to create the output to screen, we have a second viewport here, our UI viewport. That is held within a UI container. That is a helper node in Godot that ensures that whatever is on its child's viewport, so this container has the viewport as its child, whatever is rendered to that viewport is then output to screen. So we're rendering the whole 3D view in our HMD viewport. That gets sent off to the HMD, and then we are rendering a 2D view in this viewport, and that is then displayed on screen. And the only thing that we're currently rendering in our display viewport is a texture rect that actually is showing the left eye preview, or I think in this case it will become the right eye preview, because we render the left eye, send it off to the HMD, and when we render the right eye, send it off to the HMD, and the right eye is now used for the preview in our screen. So that is the way that this is now set up. But that now gives me control over how I'm displaying the texture rect. So I can blow that up or make it larger so that we see more of the center of our screen. Now remember, our HMD is rendering at a much higher resolution than our display. We're rendering at something like 2K by 1K or something like that. While of course our display on screen is only 1K, or what is it, 1900? I think, something like that. Don't get me on the exact sizes. I would need to look them up. But we basically have that room to blow it up without it getting very pixelated. Hi, Rodzilla. Thanks for coming. Cool. It's getting busy. All the usual names. Very cool. Thanks for always joining us every week, guys. It's much appreciated. So yeah, so the end result of that, if I now run our game, I'm just going to leave my headset just lying there. There we go. Is that we're actually seeing much more of our view. Now I might actually make it a little bit less zoomed in. I'm not quite sure yet, because you can see that the FPS counter is now pretty much in my left upper corner. Well, before it was almost in the middle of the screen. It was really, you know, somewhere over here, if I'm not mistaken. So so yeah, you can see that I've probably blown it up a little bit too much, and that effect is not as pronounced inside of the headset. I'm just going to hold the headset up for a sec. Let's see if the tracking kicks in. There we go. But now you guys can see the interior of the cockpit quite a bit better, and that is the effect that I have when I'm actually having the headset on. Is I think I might see it like it's a little bit more back, but it's about this. So that really is much more exemplary of the size of how things look in the inside the cockpit. At this point, you can also see a lot better what the radar looks like, because that was really small before I did this zoom in. So I'm hoping that makes the view experience a little bit better. We can see a little bit better what's actually going on, even though you're now missing some of the peripheral vision of our camera. And again, like I said, I might tweak it a little bit more, zoom it out a little bit more, and find a better balance. But you know, the other thing that is really nice about this approach is that we can decide to do completely different things in the preview on screen. We might add our settings menus in there that we don't want accessible inside of the headset, or we could do a separate spectator cam in there. Obviously that does require extra rendering power, so it is perfectly capable, you know, we're perfectly capable of actually rendering our whole scene through a third camera, and then outputting that camera onto our UI here. And you know, we could make someone who's looking at the desktop see the view from the perspective of an enemy ship, or some other things. Or you know, we could have an outside camera. Maybe at some point we'll do that, and have a camera that's slightly behind our ship, so that while I see what's in the cockpit, you guys can then see what's a bigger view from behind the ship. Those are sort of things that we can play around with and see what we want to do with those things. But the nice thing is it is now uncoupled. It is no longer that what we're seeing in the HMD has to be the thing that we're seeing on screen as well. Hi Andres, hi Tunis, hi Joseph, thanks for joining. Always nice to see some new faces too. So welcome Andreas. I probably mispronounced your name there, I'm very sorry about that. Always terrible with names. Alright, so that is our first change that we've done compared to last week, is just create that setup a little bit better so that we have a better preview in our game. Now, going back to our main scene, and that's pretty much stayed the same. So here we still have our scene loader logic. One of the things that I probably want to start getting to pretty soon is not loading straight into our level, our testing level, but to actually load into our startup environment, which will probably be inside of our carrier, and where the player is able to move from area to area inside of the carrier, where the whole game story kind of develops, but also where we have interaction with our setup and our configuration for our game itself, which also means that by the time that we launch into our fighter, we should already be in a seated position with the headset on, and we won't appear outside of our ship. That's one of the other reasons why you really want to handle that. So going back to our little demo start scene that we've been working on. There we go. So, I'm not quite sure why we started over there. Here is our plane. So the next thing that I have been working on, I've actually got the a proper collision shape around our hero ship at the moment. I played around. I think I mentioned this last week in the stream. I played around doing that for all the ships, but I found that had a very serious detrimental effect to our performance, which is why for the other ships I've created the collision shapes by using multiple primitive shapes, and that seems to be a lot more performance. I'll probably go back for our hero ship as well. I was just experimenting with that and seeing what I've done. The other thing is we now have our hero ship extend our well, obviously our plane ship, extend our friend or foe script. So the same script that we were using and the same scene that we were using for our enemies and for our allies, we are now also using for our hero ship, but with the plane scene in between, which handles all the input for the user. So that is the structure that I actually want to go for, and we'll eventually use that same structure for the enemy and friendly ships as well, where friend or foe is the thing that they all have in common. So that will have the logic that will control the weapons, that will have the logic that ensures that we have, that we can take damage, that controls the logic that we can kill off our ship, all that sort of stuff. Then there's one level on top of that, which for our player will be the plane, and I probably will rename these classes because right now the names aren't, they don't do their role justice. But this is the script that is then purely used for any craft that our player can play. So this has all the logic added that we need to control a ship with a joystick or with other sorts of input, and has all the extra things that we need because we're inside the ship and we want to be able to see the HUD and all that sort of stuff. So that is what's specific to this one. And then obviously we have an implementation for every ship that we support. So right now we just have our little fighter. We still have our where is it? We still have our old interceptor, but of course that's still just the cockpit. So I haven't really been working on that, and we probably won't keep that one around. That was just the very first thing to start with. So that's the structure that we've done there. But when we look at our let's take our friendly bomber that we've been using. If we look at this one and we look at its parent, we see that we go directly to friend or foe. So we don't have an intermediate script there. And I'm thinking about adding that, where we have the friend or foe script to have, you know, our common denominator for all our fighters, and then have a script that has the basic AI for a friendly or enemy ship built in. Might be a different, you know, script for enemies and a different script for friendlies, or it might be a different script depending on the class of fighters that we want to support. I don't know yet. That's the thing that I'm still designing. And then we finally layer this on top, where the final script that we have, the final child of our scripts, or extend, or whatever we want to use the terminology of Godot, that purely then works on the visual side. You know, what does our ship look like, and what are the capabilities of the ship? So what guns do we have, and that sort of thing. So those are all sorts of the things that we that I'm thinking about of building complete structure around this game. I probably should draw some diagrams for this at some point in time, just to make it a little bit more clear. But that is the architecture that I'm going for so far. We might change it. You know, we'll see how things go as we build this. But that is where we stand today. Okie doke. So with that structure change, I now also have made our guns work a lot better. So I am going to go into our gun script here, and I want to just go to our weapon script itself. So I still have this one to identify between whether it's a primary weapon or a secondary weapon. That might even go as well. I am not sure about that, whether we will just work with weapon groups that the player can configure themselves. And that if they want to have the primary fire the laser and a rocket at the same time, then, you know, good on them. Although I'm also still of the opinion that having those split, that the trigger always fires the selected guns, and the secondary fire always fires one of the selected missiles. That is something that I still need to choose. Let's blow this up a little bit so it's easier to see. So most of the script is still the same as before. The big difference is that we now just have the fire routine, which will fire this particular weapon, but none of the actual control of when we fire the gun is in there. So the logic that we worked on last time, that was down here, that reacted on actually pressing the buttons on the joystick, that's no longer in this script. The weapons do not control how they get fired. So their input is that from something from outside will call the fire method, and that will fire the weapon. And now that I'm here anyway, I suddenly remember that, hold on a sec, I wanted to add that this thing returns a Boolean, so that we can return true if we've actually fired the gun. So if there's any of the conditions, so here we are checking all the conditions. Is our gun enabled? If not, we don't fire. If we are in our timeout, we can't fire. If we haven't configured this thing right, we can't fire. If our ammo's run out, we can't fire. Else we lower the ammo count and we actually fire the weapon. And then obviously at the end here, I actually want to return true. So right now I'm not using that yet, which is why that code wasn't in there, but this is a little preparation for what is coming down the line, because this is going to be very important when we start implementing alternate fire. So we will come back to that, I don't know, so maybe tonight. I don't know how we are going to be time-wise, but that is one of the things that's going to change. So we still have our target. So, or both these properties, so initial velocity and target. The initial velocity really communicating the current velocity of our craft when we fire this weapon, so that we can give that as the base velocity for our projectile, and just add whatever fire velocity we want to add to make the projectile move away from our ship. And then obviously the target, who have I currently got target lock on, so that if this is a projectile that can home in on that target, it can home in on that target. But for, you know, blind fire stuff, you know, lasers, railguns, all that sort of stuff, we're just going to ignore that parameter. But it is important that the thing that causes the weapon to fire tells the weapon what it's currently locked on. The rest of this is pretty much the same. We instantiate our projectile, we set our collision mask. Now, obviously, right now, because we now can, we're going to use this for weapons for both on our player ship, on our friendly ships, and on our enemy ships. We set the collision mask accordingly. We then position our projectile, and we fire it off. Now, one thing that I did change, or did we do this way the last time? Yeah, here we did that with the projectile. I've changed it, that I'm actually always using has method to make sure that the projectile that we fire has a set target method. They should, because we are extending from our projectile script. But just in case that's someone at sometime down the line I forget, or I want to implement something completely separate for whatever reason, then that check is there that, you know that I'm not calling that method unless it's possible. But that sets the target, lets the projectile know this is the target that we're expecting you to target, or to home in on. And finally, we communicate our initial velocity so that the projectile can do the rest of the work there. Do a cooldown, play our sound, and thanks for coming. So most of this is still the same from last week. The most important thing is that it's just a fire method now, and the control has now been moved. So that is the bit that has now been moved. Into the plane script. So that is the script that sits between our plane implementation and our original friend or foe. My phone is suddenly behaving a little bit weird. It's okay, it's still running fine, so this is going to Hi, see you, my rush boots. Welcome to the stream. Yeah, this thing is being a bit silly. I'm just going to ignore that. So, where were we with this? Okay. So, again, like I was explaining before, we now have this sitting between our friend or foe, our base class for all our ships, and our actual implementation of our player ship, and this controls all the input handling for our plane, and including the movement, which we've had for a while now, but now also including our fire logic. When we look at our enemy ships or our friendly ships, like I said, I'm going to put something, a similar class in between as well, in which the AI then decides which guns to fire. In which case, they basically do the same thing. It's just now it's the AI in control instead of reacting to a button on a joystick. The whole smoke and mirrors one with gay asteroids. Might go there. I'm not sure if I'm gonna go as crazy as I did in my smoke and mirrors video. But I am planning to go back to the asteroids in here and do much more with them. And one of the things that I'll probably be looking at is indeed increasing the number of asteroids that we render by implementing an LOD system. But I wanted to get more of the game working before we go back playing around with asteroids. The asteroids are fun. They're nice dressing, nice scene dressing. But in the end, they're just asteroids. We want a ship. We want to be able to fire on things. Okie doke. Cool. So we can see that there's a couple of new variables here that we are controlling. The first is actually this whole thing here. Boom, boom, boom. So we already had our selected target. That is the ship that we've currently got selected. So when we run our game, I'm just going to run it just for a minute. I'm not going to worry about my headset at the moment. All right. I am going to see if I can tilt it a little bit. Or no, I need a tracking before it does that. That's a shame. I don't see enough of what I want to see. So when I select something, we have our target selected. In this case, we have our carrier selected, and then we go to one of our enemy things. There you can already see one of the other things that I've added. We'll come back to that in a minute. And then we've got one other friendly, another friendly, another friendly, and we're back at our carrier. So whatever unit we've currently got selected is stored in that selected target variable. And when I press the button on my joystick, we're just cycling through whatever targets are visible to our radar. So that radar screen in the middle and our target selection here, they're linked to each other, and we just cycle through those. So that is what this does. But last time, in the last video, that was also the variable that we were sending to our rockets. So regardless of whether we just selected it, and regardless of where it is in our scene, our target or our missile was immediately locked onto that target, and it flew to that target, and thanks for coming. Now, that's not how most of these games work. That's not how we want our game to work. We actually want to have a little bit more payoff when it comes to targeting missiles, because missiles do a lot of damage. So if you would just be able to spam them away and it would just fly to the target, you would win every fight. So the thing that you want is you want to make sure that the player has to keep the enemy ship in view for a certain amount of time to actually give it a target lock, and only then do we communicate the target to the missile so that the missile flies to that target. And that makes using missiles slightly more dangerous, but the payoff is it does a lot more damage. So so that is our locked target variable. So we now have a target lock system, and only once the target lock decides that enough time has passed with the enemy ship in view, then we set our lock target here, and that is the variable that we communicate when we fire our weapon. So if we don't have target lock, that will be empty. If we do have target lock, that will be communicated. We have a curve here. I'm going to come back to that in a minute, because that is for our little animation that we just saw. Am I using that one for the animation, or am I using that for the sound? We'll see in a minute. I can't remember. I wrote this last Sunday, so it's a little while ago. No problem, Speedy. That's it's a good suggestion. We are going to come back to it eventually. In order to track our target lock, we have a variable. -1 is the default, means that we don't have a target lock right now. The moment that we select a target, this is actually set to 0, in which case we still don't have a lock, but we have a target that we're tracking. And then as we get our target in view, we're going to increase that counter until it reaches 1. And once we reach 1, that's when we have a lock. We have a lock duration. How long is it going to take? How long do we need to have our enemy in view before we actually get a target lock, which is currently set to 5 seconds. And then a very important variable, our lock angle. So we're not going to just, lock onto the ship, just select it, and then 5 seconds, and then we can fire our missiles. We have to keep it in view. And this gives us the cone that we need to, within which we need to have our enemy in view. So we now have a 45-degree cone. That means if we have our vector going straight forward in the direction that we're flying, in the direction that we're facing, then 45 degrees in any direction of that makes a cone that sort of projects outwards. If our enemy ship is within that cone, we are performing our target lock logic. And the moment that the enemy ship is outside of that cone, target lock doesn't work anymore. We reset our counter, and you lose your lock on the enemy ship. So that's what those variables are for. Let's go have a look at actually how it works. So that's all stuff that we've built before. I've put a few of the functions into a bit of logic into functions. So we now have a handle control input function here, which is purely doing our flight control that we wrote a couple of episodes ago. So I'm going to fold that. Then we have our target input. So that is the logic that handles us selecting through the targets. So that is still pretty much identical. It's just that more logic has now been moved into our select target. So whenever we select a new target, we call this function, and that updates the selected target that we have. That updates our target indicator. That is the thing that shows a little squarey thing on the screen. And it updates our little view on the left side, which is the little bit of code here. There's a little bit more code there because I've offloaded some of that into a subscene, but not all of it. I have offloaded the whole target indicator into a subscene. We'll have a look at that in a minute, because that's also doing that that rotating triangle or diamond shape that we had when we were getting lock on our enemy target. So this is purely therefore cycling through the targets that we can lock onto. So let's fold that in. So here's our handle lock logic. We'll come back to that in a minute. That's the bit that I want to talk through a little bit, and our fire logic. So those two in conjunction. I just want to first skip to our physics process and our normal process, how that now is handled. So in our physics process, we are checking, first of all, how fast we're going, because that's an input that we need. We have our handle control input. That is our input of what our joystick is currently doing. That controls how our ship flies, whether we're accelerating or whether we're turning. And then we have our fire handle that actually controls whether we're firing a weapon. So we're going to look at that in a minute. And in the process, we are checking which objects we have in view of our radar. That's something that I want to do a little bit more with, because right now we can see everything, even enemies that might be behind a space station or might be behind some other obstacle. Right now, as long as they're inside of that sphere, that collision sphere that we have, we can see them, which is not really very realistic. We want to be able to lose track of enemies if they go behind something. So we're going to have to do something about that. That is also, again, for a future video, but we are going to be talking about that. We're then going to handle our target input. So while our control input for our behavior of our ship is in our physics process, the input for actually selecting our targets is in our process. That's just because that isn't directly influencing what our physics engine is doing. So that's why we have got that there. And the same for our lock handling. So the timer that controls whether we have locked onto our target is handling there. And finally, we're just calling the little globe thingy to tell it, here's the enemies in view, and here's the target that we currently have selected. Go and update. So we've got all the little green dots, all the little red dots, and we've got a white dot for whatever our selected target is. So that is how all these things are broken up. So now let's get to the juicy bits. First, they handle fire input. So this is still not finished, but it's already a lot further along to where we are. Right now, if you use the primary fire, we fire all primary weapons. And if you use the secondary fire, we fire all secondary weapons. And that is something that we're going to change. We want to actually have some fire patterns. So yes, we could configure that we want to shoot all lasers that we have all in once, or we want to cycle through the laser. So we fire one laser, and then we fire the next laser, then we fire the next laser. In which case, we probably will do something here where we are reacting on that variable that I gave back, that if we indeed fire, we cycle to the next laser, but we might introduce a delay and things like that. So that's something that I still want to work on. For now, the simple way that it works is that, first of all, it's not controlled from our player script, from our plane script, instead of from the weapon script. So that logic changes depending on whether we're an AI or whether we're a human player. But for now, it just goes through all the hardpoints that we've defined. So that was very important when we look at our, we need to go back to our plane. So we have our hardpoints, and this is actually on my friend of foe one, so that everything has it. We have a hardpoint spatial, that's just a placeholder. But then on our fighter, we have added hardpoints, which are all the locations on the ship that we can attach a weapon to. And then we have a weapon under each of those. So our script is simply going through all the hardpoints, finding all the weapons that have the correct fire mode, and then telling that weapon to fire. So that is as simple as we've got this right now. And this currently only works because we only have one missile launcher. If we had two missile launchers, we would always be shooting two missiles at the same time, which is not what we want. But again, my point here is we have a start. We now have the logic in the right place, and I can start working on improving this logic once we have more intelligence about knowing which weapons we have and allowing the user to configure weapon groups. So for next episode, but a definite big step forward to what we had last week. And then the target lock logic itself, where we're checking if we have a target selected, and if that target is an enemy, we're not going to lock onto friendly ships. So we're not going to be able to shoot our rockets to our friendlies. There is a friendly fire protection there. So if we don't have it, we simply go here, we set the target lock to -1, we set lock target to null, so we know that we're not there. And we do a little bit logic around the sound. I'll come back to that in a second. And we're also telling our target indicator. So that is that, again, like I said, that's that little square that we use to show the enemy that we've got selected, or the friend that we've got selected, and that has all that logic to create that diamond shape that's rotated. So we're going to have a look at that in a minute as well. Now, when we do have an enemy selected, what we're taking here is our forward-facing vector, so the vector pointing straight forward out of our ship. And then we're calculating a vector using the location of our target, and we subtract the location of where we are, and we normalize that vector. So that forward vector gives us our forward vector, and this gives us a vector that points to where our enemy ship is. And now we need to know the angle between those two vectors. And I believe that I have mentioned this in a previous video, but it's never hurts to repeat. To get the angle between two vectors, you simply perform the dot product between the two vectors. As long as those vectors are unit vectors, so vectors that are of a length of 1, which is always the case for our base of Z, unless we scale something that we're not handling, or we're not doing scaling here, or we know that we're not doing that. And that's why we normalize the target direction. They both need to be normalized vectors. We do a dot product between those two, and that gives us the cosine value of the angle between the two vectors. So now we have a cosine value. And that is also why when we go up here, I took our 45 degrees, converted it to radians, because of course we always use radians when we calculate things in angles, and we take the cosine. So that gives us the cosine value of a 45 degree angle that we can compare against. So with that, we are checking if the value of the angle is bigger than that lock angle, that 45 degree value. And it needs to be bigger. That's really weird, because I told you that we wanted to have something that's in between that. So we want to have something that's between 0 and 45. But the thing to keep in mind is when you take the cosine of an angle, if the vectors are aligned, we get a cosine of 1. If the vectors are perpendicular, can I do this? My hands are hurting. Then our cosine is 0. And when our vectors point in opposite directions, our cosine is -1. So our 45 degrees, if I have correct, I think by memory that's 0.7. So we want any value between 1 and 0.7. Anything smaller than 0.7 means that our enemy is further away from our front. We're no longer facing that enemy. So that is why we are checking for bigger than. So if it is bigger than, again, we update our target lock. If we are smaller, then we say, no, we no longer have a target lock. Back to -1, lose our target, and we start over again. So here we're simply checking if our target lock is -1, or we've changed the target that we are locking onto. That means that we have to reset our target lock. So what we're doing here is we're setting our lock counter back to 0. And here I did make a mistake. We are actually immediately assigning our lock target to our selected target, even if we haven't got our lock. So we'll see in a minute that there's an extra check when we communicate that to our weapons. If we were targeting this target, then we are simply adding our delta version value, the amount, the number of seconds passed since the last frame, which will be, you know, a very, very tiny number, and we're dividing that by our lock duration because we're going to stretch that out to that 5 seconds. We're adding the time passed to our target lock. So our target lock will start at 0 and it will go all the way up to 1 if we have hold our target lock for more than 5 seconds. That is what that logic does here. So the moment that our lock target is set and our target lock value becomes 1, that is the moment that we have our target lock. And if we go back to our fire logic, then we can see that we are checking that here, where we're saying target is null. If our target lock value is 1, we've reached that full the full 5 seconds, so our target lock has got the value of 1. Only then do we assign lock target to target, and that is then the value that we're sending to the weapon. So we're only sending a target if we have a target lock. Thank you, Jan. That's nice words. Thank you. Nice sentiment. I'm glad you are enjoying watching me write code. Never thought people would find that interesting, but I am glad that you guys are along for the ride, because I definitely am having a lot of fun. Too much fun, I would almost say, because I have a few other things that I really need to start working on and start finishing, because, you know, there's other things that I want to do on my channel. But for now, tonight, we're having fun with this. So the last part of this, and you guys probably heard it, again, I have my sound off, or else my microphone picks it up and we get a nice little echo going on the stream, which I don't want. But I've added a little target lock sound. So as we keep our lock, if it's for 5 seconds continue, we're going to hear beep, 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 that sort of speed up of beeps. And then once we've fulfilled the full 5 seconds, that becomes a tone. I've got horrible sounds for this. I really need to find someone who is actually good at making sound effects or things like that. But for now, I got some horrible beep sounds that we put in here. So I'm not quite sure if I'm going to keep it that way or if I'm going to do a different sound effect. But I did want to have some audible feedback that tells us whether we have a lock on target. If these sound effects are too loud, by the way, let me know. I'll turn it down a little bit on the stream. But I think I was smart enough to turn it down when I was doing this. Let me actually double check that, because I did that when I recorded my update video. Did I also do it here? Oops, sorry about that. I almost lost my camera there. Yeah, so that's set to the same value, so it should be good. Okie dokie. So what we're doing here is, if we have a target, this is just in case I forget to set it, because again, my base classes, I'm leaving these sounds empty because I want to be able to configure different sounds on different ships. So we have a little bit of leeway there. We might even go to a point where different weapons get different sounds. So that one I'm not quite sure about yet. I'm still thinking about that. Because it's not really related to the weapon. It's your targeting computer that does this. So I'm not quite sure what that is, what we do there. Anyway, if we have that, we're going to see whether we should be playing. So if we have a target lock, then we should play our continuous beep. And here I'm simply checking if I was already playing, if that value has changed. I'm either going to start or stop playing that sound, because that's a looping sound. So that's why I'm doing it that way. I'm also have our intermittent beep, which is a separate audio stream. And here I'm simply checking if I have a sound set up and my target lock is between 0 and 1. So remember, -1 means I don't have a target lock, so I don't want to have any sound. But as my target lock goes from 0 to -1, I want to hear a beep. Now here comes a little bit of creative logic. And that is that we are going to send our target lock through our curve. And that means that instead of having a beep that goes on a fixed interval, beep, 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 we are going to make that a curve. So we go beep, 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 and speed it up. And I wanted to be able to configure that. So when we go back to our script and we go here, we'll see that we have a lock curve here. So we've created a lock curve which starts at 0. So when we get a lock value of 0, this returns 0. And we delay the speed at which that rises. So instead of that being a straight line, we're kind of ramping that value up, and that allows us to make that speed up of sound. And the steeper that curve is, the faster we have those beeps. And the way that we do that is by getting that interpolated value. So all that this is doing is we're inputting our value, and then we're getting a new value back based on that curve lookup. And then we're doing a modulus with 0.1, a floating point modulation. This basically means that we are dividing our value by 0.1. It's actually multiplying it by 10. And then we are taking our remainder value, whatever is behind the decimal dot after that calculation, after that division. That's the bit that we get, and we're checking whether that is smaller than 0.1. So as we're ramping up, we are going to get 10 points on our line where our remainder drops below 0.1 or 0.01, and that is the moment that we trigger a new beep. So the steeper that line, the quicker that is reached, the quicker the succession of beeps is. But I am making sure that, because there might be a couple of frames where that is true. We want to make sure that we only beep once. And in that respect, I'm actually going to change this to being 0.5, I think. Is that safe? 0.1. The reason I'm doing that is that I do want that, because I've now got that beep protection, and I forgot that I did that. I don't want to risk that we are having a frame take too long to render. Let's say that our frame rate really drops, that we don't ever reach that 0.01. So it's better to have that a bit higher, but we have to make sure that we reach a few frames where we do get above that, or else we won't reset our beep. So that is what our beep 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 does. All right, nearly through all the changes that we've done off camera since the last stream. So the last thing that I want to have a look at is that target indicator script. So let's go and have a look at that. We're going to first look at our look. So we have a target indicator. So this used to live inside of our plain script, but I've moved that away. Again, we have another curve here, again called lock curve, but in this case we are using it for that zoom effect to not make that a fixed zoom, but again to sort of zoom in very fast and sort of slow it down in this case. So here we're not speeding it up, here we're slowing it down as we are zooming in on our target, and that gives that effect. We are rotating at a fixed effect. We then have a node here, so a non-3D node, just a plain node, and then again that is to disjoint the objects that follow from our current location of our ship, so that these are all handled in global space. Then we have our target select, which is our little target rectangle. Now this used to be a box, but I actually changed it to a rectangle. I thought that was a nicer way of doing it. So we're going to position this on our target ship. So if we target our enemy ship, it's going to be positioned on that ship, and then it's going to always render that selected target reticle there. Now what's special here is when we look at our material here, and this is now a shader material, but it started life as a normal material. I'm just going to very quickly, I'm just going to create a new mesh instance because I want to show you guys this. And I'm just going to go, no, it's geometry, isn't it? Yeah. I'm just going to create a spatial material on here. And the thing that I'm using here is I'm using a Y billboard to make sure that that thing is always facing the camera. But I'm using this, I'm not turning on this keep scale value. Is it that one? No, it's not that one. No, it's a fixed size. This one is the one that I'm using because I am actually scaling it to get it to the right size. It's this fixed size thing. So the weird thing about this fixed size, this is some really cool magic that gets introduced into our shader that makes sure that our square is always drawn at the same size. So we are using that billboard thing, but we're actually using it with the keep scale to define what the size is. But once that size is set, that is the size that we're drawing it in. So if we go and look at this thing, where is it? Why don't I see it? Because that's our selecting rectangle, isn't it? Why am I not seeing you? Did I make it too small? Might have made it too small. Let's just go and, because this is going to be overwritten anyway, so let's zoom it up. There we go. So zoom it up for just to make it visible. So here we can see our reticle now, but regardless on how far or how close we are to it, it's always the same size. And that's something that I really wanted to have, because when our enemy ships are very far away, because we're faking that we're kind of rendering this inside of the head-up display of the pilot. You know, even though the ship might be so small, so far away that we can't see it by the naked eye, we're using our targeted system to still see it. So we want this square to be still of a good size that we can see it. But when we get closer to the ship and we really see it, we don't have to have it always be as big as the ship. The fact that it now becomes smaller, that isn't really a big issue. Hi, Ensign Fu. How are you tonight? Thank you for joining again. Nice to see you. And we have to remember to put this back to 1. I think there's the scaling logic is set in our script. Or scaling value. I'll get there in a minute. I think it's overridden, so even if I don't change it, then it should still be fine. So let's go and let's look. So yeah, so that fixed size, really cool little setting. But I changed it to a script, so I should have done that a little quicker. But if you right-click on a spatial material, there's an option in the menu, say convert this to a shader material, and you can actually see the shader code that Godot has created for that that object. And I did that because I wanted to remove a whole bunch of things, a whole bunch of standard things, and I wanted to do a few small tweaks to this logic. I think I just removed a whole bunch of things. But I wanted to make sure that I could reuse that shader both on the target lock and the selected target, but I could control them separately because they are being scaled differently, and one is being rotated. I'm not completely sure. I think it was mostly because of the coloring and stuff like that I wanted to do. Anyway, yeah. So they are it's a shader material now. So you can see the logic. So we have a target lock, which is our nice little box here. Sorry, our selected target, and our target lock is now a little triangle. That's just a bitmap, right? It's just a bitmap with a line and transparent center. It's not a special object or anything. It's just a quad mesh sized so that it nicely fits in there, and we're just going to scale it up to start with and scale it down to zoom in on our object. So that is all handled by script. I'm actually, just to be safe, I'm going to reset that back to 1. So in our script, we handle a function, or we have a function that allows us to tell it which target we've got selected. So that's being called from our plain script. Whenever we change the target, that gets told to this. If we have one, we are going to set the process to true. But if we do not have one, I'm not setting it to false. We're doing that in the process because we want the process logic to run one more time. And if the object is not selected, we are making everything invisible to make it disappear. And here is where we are setting our process to false. And that's just an optimization thing. If we haven't got a target selected, we don't want to keep running this process loop just to have it do nothing. That's just a waste of performance. So that's just something to keep in mind. In Godot 2 and earlier, you always had to specifically set process to true, or process would never be called. And there's now some logic in Godot 3 that as soon as you add a process function, that is automatically defaulted to true, and you can still turn it off to have that logic not run, but by default it's on. So so be aware of that. Why use a mesh instead of a Sprite 3D? Habit. I guess you could do a Sprite 3D with the same material. It ends up doing pretty much the same thing. I think, as far as I'm aware, Sprite 3D is just rendering a quad, just the same. I use a quad mesh. No real particular reason, to be honest. A habit. Just used to doing it that way. I don't think it really makes much of a difference. So the other thing that we then do here is set our target lock, which communicates our new target lock value. So that's our value that's going from -1 if we're not locked, from 0 to 1. Now, I'm not sending through the target itself because we already have that. Because remember, the selected target is copied into the target, into the lock target variable. It's always the same one. I don't need that information here. It's double. I needed it in the plane because I wanted to make sure that we had some way to see if a target changed. So we had selected enemy A, we're now selecting enemy B. That has to reset the lock. So I needed to remember which target we were locking on before the selected target change. In this case, we are we don't need those two values. And I probably can optimize that. I probably can still do it with one variable in the plain script if I really wanted to, but it works the way that it does right now. We have a set color, which is just a one that allows us to change this this color that we've set here. So that's just a property, and the only reason we have that here is that we want to copy that color onto our materials. So we would never call that ourselves. That's always called by changing the color here. So that's basically a private variable instead of a public one. Should probably underscore that one. In our Additive function, we're just defaulting our lock material. That's all fine. And we're making sure that our color gets updated. That was the reason why I split out those scripts now, or those materials. Now I remember, because we are actually changing the alpha value of our lock so that it goes from completely transparent to completely opaque as you are targeting an enemy. We'll demo that in a minute. You can see that. So my old code for my cube is still here. That actually can go. That is no longer relevant. That was for when I had a targeting cube instead of a targeting square. Let's zoom this in. I should have done that earlier. What are we doing here? We have our selected target. We're creating a new transform because we don't want the rotation to be copied. We just want the position to be copied. We are copying that into our quad, and we're doing a looking at here. Or we're doing a looking at first, and then we are copying into our quad. So I'm actually not using, that's right, I'm no longer using the Y billboard functionality here. That is the other thing that is important here. I'm just using the fixed size. There is a problem in VR that does not happen on desktop when you are using a Y billboard. If you have a billboard that is going to be straight depending on your camera. So as your camera moves, that billboard moves with it so that I see the same side of that billboard. That's what the billboard is doing. But within a Z-plane, it is always facing the same way. So basically, its outward facing is the exact opposite of the direction that I am looking at. And that is what the billboard logic does. Now, the weird thing is, if you do that on a desktop and you strafe or you move around, and that position that this billboard is, that looks really good on a desktop. But when you are looking at that stereoscopic, you can actually see immediately that is a flat plane. Your mind is so good at interpreting that square object, and that square object actually moving away from you as you look away, because your distance to the object actually changes, even though it's still facing you. It becomes incredibly clear to your mind that it's a square thing. While if you make sure that you're always facing it to the camera, not in the same plane as the camera, but actually facing the camera, so that the normal outwards points directly to your camera, then that illusion keeps working in VR. And that is why I am doing it manually here. I am placing, or I'm creating a new transform where the origin is being set to where our enemy target is, and then I'm using the look at function to make it face the camera, face the location of my ship. I am using the global position of the ship here, while I might be sitting slightly forward from the center point of my ship. On the sizes that we are working here, that does not matter. And that prevents me having to send through the location of our player. Also, I would have to move that target indicator as a child of my my camera, probably, if I wanted to do that. But because of the scales that we're working on here, that small distance doesn't really have an effect. All right, so once we do that calculation, we are setting that to our selected target, and we're making our selected target visible. Now remember that our lock is a child of our target, so that immediately gets that same orientation. We don't have to repeat that for our target lock. Our target lock is already positioned correctly as a result. So when we look at our target lock, we're simply checking, if our target lock is -1, that means we don't have a target lock. That means that we are going to make this guy invisible. We don't have to make him invisible here because, again, we are making our selected target invisible. Any child is invisible. As a result, our target lock diamond becomes invisible as well. But if we are having, processing our target lock, what we're doing is we are starting with our base color and we're changing our alpha to our target lock. So remember, if we started just getting a lock, we are at 0, so that becomes transparent. And once we have lock, that's moved all the way up to 1, which is completely opaque. So that is what we change the color to. So our color goes from totally transparent to totally opaque within the duration of that lock in those 5 seconds. Then I'm using that curve that we talked about, the curve that is on here, this guy, to scale it. So we're starting it at a scale of 50, and as time goes by, as we approach our target lock, we are slowly scaling it all the way down to 0. And don't worry, in code, I am adding 1 to make sure that if we've scaled all the way to 0, or our curve is 0, we're actually at scale 1. So we're actually going from 51 to 1. But we're doing that as a curve so that we have a speed up of our zooming in effect of our making our scale smaller. That starts really fast and then it starts to slow down until we have a lock. So we got our curve, and all that we're doing now is we're creating a new transform, and we're doing 2 things. We first start with rotating our transform. So here I'm just, my end rotation, actually my starting rotation is 45 degrees, and we are then rotating that by a further 90 degrees as time progresses. So our diamond starts like this, and then it rotates 90 degrees over that duration as we zoom in. So that gives that nice little zoom in effect. And then obviously for the zoom, we add the scale. And that's really all we need to do for that. Finally, we make it visible in case it's not visible yet, but that's only the first frame that we need to render it. So all that code amounts to the following working. All right, let's do a demo where we are. Alrighty. Actually, I need to do that like this. There we go. So, again, our frame rate is a little low while we're in the carrier. I still need to get a better carrier model. There we go. So, there's our 3 enemy ships. And on purpose, I am going to start like this. Our ship moved away from it. And we're going to select our guy. So we can see now that we have that little target rectangle. I hope that is large enough to be visible because the shield does hide it a bit. Should have probably... no, we wanted to leave the target lock away. Anyway, you see now I'm in that 45 degrees and we start locking and we got locked. Now if I move away from that 45 degrees, I lose my target lock again. If I go back in, eventually lock. And now we have the annoying sound when we get locked. And when we go away, then it's gone. Now one thing that's of course important is if I shoot while I don't have lock, it keeps on going. And when we do have lock, we have to wait until the lock's there and we shoot. Our missile is doing the logic that we wrote last week, and it's actually hitting it. I also add a little whoosh sound when you fire the missiles, which I thought was kind of cool. Hitting, there we go, and we destroyed our little enemy ship. Okay, so I want to go a little bit further off. Let's fly away from these guys a bit. Flying off. Obviously when we're looking this way, it looks like we're still standing still because there's not much happening. There we go. All right, so let's go and turn around. Alrighty, where are you guys? So now our little ships are very tiny. Now it's still that our shields are too visible. It makes it too easy to see our enemies. That's still something that I want to do. But here you can really see our effect on having those shapes be a fixed size. So even though our ships are very small, we can see our target rectangles. So I don't have my friendlies yet, so I want to go a little bit closer to my carrier until we can select those guys. Let's wait until we see some green dots in our scope, because the same thing happens for these guys. Now, yeah, you guys might be able to see the square, but the carrier does make it very hard to see. So I actually want to go and select one of the outer guys. And there we can see a lot better. And here it's really clear with the friendly ships being that small that the square does show it a bit better. And maybe I need to change the color of our square a little bit. Oh, we're going to hit our asteroids. Yep, we're going to hit our asteroids. I'm getting all dizzy now. Alright, let's see if we can fly away from these guys without hitting them again. But yeah, our little square is a lot more pronounced there. I'll probably have to work on the color a little bit more to make it stand out a bit more. So, and again, like I said, our targeting isn't working on our friendlies, only on our enemies. So again, you know, right now we should be pretty far away from our enemies. And yeah. Same for the targeting. Maybe I need to tone that one down a bit because it becomes very clear where our enemies are. It's going to be very easy to follow our enemies when we have target lock. But yeah. I do really like how well this works. Boom. I'm out of missiles. Got one shield down. I still need to do the shield recharge. But yeah, there we go. Okay. Making some good progress here. All right. Yeah, that interplay bakes all those sort of, you know, this is really where knowing all the nodes and especially the resource side of all the objects that are available in Godot really pays off. Now, very often you see that these things exist because they are used on other nodes, but know that everything that's in there is also available to you to use. So once you see that there's a curve object, even though that is not drawn in the 3D side, it's purely accessible through the property manager. It's something that you can use. And once you start looking into those things, you know, it just, you can do some really cool things with that because, yeah, you know, like I've done here, is, you know, you just quickly draw a curve to do that. Now, this is baked in 100 steps, which is more than enough. It does interpolate between those steps. But let's say that I put this in 10. I was actually hoping that would update that one. Does it? Maybe that's even enough for that to work. Or is it just not? Yeah, now we can really see. So just wanted to show you guys how that works. So you can see that resolution of that curve becomes really horrible. Now, 100 is probably incredible overkill for the resolution of our curve. It means that we're basically not interpolating at all. We have all the variables, all the values that we really need, but you know, it's good enough. But it's not the smooth line like here. You can see that there is a little bit of coarseness to that, in part because of the way that this little graph is drawn, of course, but also because this is just a very you know, a very low resolution sort of curve that we have. But it's fine. It's more than enough for our goal here. You can see how smooth that zoom function was. Master Ox really wants a desktop version without the headset. Maybe. Like I said in my previous video, technically it's not a difficult thing. It's just a matter of turning the head rotation logic off, and we might do then something with the mouse if you're inside of the carrier where the mouse allows you to look around, but the rest of the UI is the same. Obviously then the two buttons on the mouse will be your primary and secondary fire, or your primary select and secondary select in the menu system. Technically that is all fairly easily done. Whether the game will be as fun to play is something that I wouldn't play it on the desktop, but I'm spoiled. I have headsets, so who knows? We'll see. Might do it. I'm not that far along yet. The targeting system, seeing that in another plane? You mean like you would look when one of your friendly teammates is flying close to you, you could see his user or his interface, his UI, maybe? Could be interesting. I think there's a lot of overhead for something that you would only be seeing a few frames, and most of the game you wouldn't. I'm not sure. As far as replicating it, hey, that's why I'm doing these things, mate. If you find usefulness in the code that that you see here, again, I'm not sharing this project right now. I talked a bit about that last video. I don't want to go into that too deeply in this video, but while I am looking at some point sharing the code side of this project, I don't want to share the project in its entirety, in part because of licensing issues, but also in part of my wish of eventually turning this into a full game and potentially selling it. But any code that you see here, you know, pause the video if you want to really read it in more detail. Copy it, man. If you can turn it into something fun for your game, go ahead. You know, use it as best as you can. That's the learning part of this and the sharing part of this. If you guys find what I'm doing useful to use yourself, please go ahead. Steal my code. I don't mind. That's why I'm doing these things. Like I always say, a thank you in your credits is always appreciated, not required. Yes, all the projects that I share with my tutorials, I share under an MIT license, which officially requires that. But I'd be happy if you do it voluntarily. I'm not going to chase anybody because they don't say, you know, I looked at Bastion's videos and I learned some of the stuff that I'm doing in my game. Yeah. So, well, the targeting system is not particularly difficult. No, it's not. It's just a globe with a couple of dots inside. So. And the logic itself for the targeting system, you know, there is more that we're going to start adding here as time goes by, but you can see with relatively simple logic, you can actually create quite a complex system going. So it's pretty cool. Avatar is, yeah, when you look at that UI, and again, one of the things that is very important to know is I just downloaded this ship from the internet, right? This is a ship that came from CG Trader. What was the key combination again? No, that's not what I wanted. I always forget what the key combination is to do this. Yeah, there we go. Now I can free fly. What I just did, by the way, is Shift F. If anybody wants to know it, when you press Shift F in the editor, you can now use WASD to move around. So, what is it? AD, WS, WS. And you can use your mouse to kind of like FPS game inside of Godot. So for fine control of moving around, that can be pretty handy to know. So Shift F to go into it, Shift F to get back out of it. So looking around our little cockpit, it's very important to know this is a model that I bought for a couple of dollars on CG Trader, just so that I had a model that we could use here. And you know, while it has the fixed little screens, I'm going for a holographic UI, which I think I didn't copy it from Avatar, but yeah, absolutely agree. Seeing that sort of UI in Avatar, especially because I'm one of those crazy people who went to see Avatar in a IMAX 3D cinema. That was where I saw it the very first time with the glasses on, and having that executed so well in that movie, brilliant, breathtaking. That part of it, the design, amazing. Now, again, that is not the reason why I'm doing the UI like this. The concepts for these sort of UIs have been along way earlier than then they were applied in Avatar. Just that in Avatar is the first movie that I can recollect that it's really executed that well, especially if you see it in 3D. But the ideal scenario here for this game is that eventually I'll be working with a 3D artist to build a plane that is meant to be used with this sort of interface. And then we'll have a cockpit that doesn't have displays like this. It will all be designed around our controls. But I want to build the controls first. So we have a control for showing our selected target. And this is not even complete, because we want to see shield stats here. We want to see health of the enemy plane here. At some point in time, we might even make our whole damage system more interesting by being able to damage different parts of an enemy ship. So you could take an engine out or something like that. Don't know. We'll see how far we go. But it becomes very important at that point in time that the assets are actually created for that purpose, because you need to be able to identify those parts of the model. I do have a friend who's a 3D modeler who's offered to help out. He's busy on a project at this point in time. But once he is done, he promised that he would do a few things, even if it's just stand-in work. But who knows? You know, I love his work. He also did the racing track in the original vehicle tutorial video that I did, like the first or the second one, where there's a complete track that I. No, it's not in the tutorial. It's in the video that I did to announce the tutorial series. There's actually a complete track that I run on, which is a model track, which is modeled by him, Clelio, and he offered to do a few things for this as well. So yeah, we'll see how we get there. Right now, this is a stand-in model, so it's a bit of a hodgepodge scenario right now. We have a cockpit that's not designed for a holographic UI. We're putting a holographic UI in there, so it looks a little out of place, but that's just because we're using a stand-in model for now. Get the ship UI in like tabs or just one plane. Yeah. So like I said, I'm probably not going to be using the UI in this ship at all. They're all going to be of a holographic variant. Obviously, at some point, we do need some 2D type interface elements, but they will be projected screens inside of the ship, and that is something that I'm not sure yet. Have a look at, if you look at Elite Dangerous, they did it really nicely. They did context-sensitive screens where if you play the game on desktop, they are all visible pretty much in your peripheral vision. But if you're in VR, actually where you're looking, the screens will come into view and you can interact with them. It's really, really nicely done. Another game that has some really impressive UI elements is like Valkyrie. If you play Valkyrie, they did some amazing stuff with the UI in that game. Very, very inspired by taking the next step with what you can do with VR. You know, something that you just can't do in a desktop environment. Because you don't have that depth percentage, so it doesn't pop out the way that it, you know, just like the energy banks there, which is, you see this L-shaped, it's like an L-shaped bank, and then inside there, you know, the L-shaped bank is physical, it's a metal thing that they modeled, but then inside is a holographic display that shows you the capacitor charge of your ship, the amount of energy that you've got available to do things with. Beautifully done, really impressively done. And that sort of thing I wanna do here as well, because I just think it works. It really showcases VR in such a nice way, because you can do the same thing in a desktop game, but it just doesn't pop out. It doesn't have the same effect as it has in VR. Okay, I think, wow, we've almost used up half the time that we have tonight just to talk about the few things that I added. Although I hope you guys have enjoyed that little journey and looking at all the things that we have. So the next thing that I want to tackle is the problem that we right now have when we fire our missile when we don't have a target lock. Or the fact that if we overshoot our enemy, we keep our target lock, and the missile just rotates around and eventually hits the target if it doesn't time out. And I actually want the missiles to be a little smarter, to actually make them a little bit more dumb. I want to make them smarter in the sense of that if we fire them before we get a lock, and they are heading pretty much in the direction of our enemy, that we actually do get a target lock. But we're making them dumber because we can also lose that target lock if we overshoot our target. And that's going to be especially important once our targets start moving. And that's also, once these missiles get shot to us, that gives us options. Once we know how these missiles behave, is we know that we can evade a target or a missile by maneuvering in a certain way. The other thing that's going to be important there, which I am not going to do yet right now, even though we are going to make some of this logic settable on the missile, is that eventually we want to have different missile types. So we might actually want to have a fire and forget missile that you shoot off, and that's the only missile that can acquire a target after it's shot, while our normal heat-seeking missiles or our normal radar-guided missiles need to have the target lock before they fired, and we might even not allow them to fire without a target lock. That is one of those things with I'm not completely sure about whether we'll have 3 types of missiles, or whether we have combinations, or if we let some of the missiles do the same logic. That's once we're further down the line in the gameplay area, we'll decide what makes sense. I'm all for choice for the player, but I also sometimes think too much choice complicates the game. Yeah, if it's not overloaded or overdone, once we start doing holographic displays for the sake of holographic displays and fill the entire cockpit up with holographic displays, then the effect is going to be very distracting. It does need to have a purpose and serve a function. So, but again, that is also where starting to work with the 3D artist is going to be really instrumental, because the design of the ship is going to be very influential to what sort of UI we're going to be able to implement. So I'm looking very much forward to working with some 3D modelers on that, and whether that's just going to be my friend or whether there's going to be other people involved, we'll see. That's time will tell. We're not that far along yet. Right now, it's all a hobby. It's all just for fun. And that's also, the way that Clilio treats it. And who knows, if it grows, this becomes a really interesting project, I think. So, where were we with this? We're going to improve the missiles. So, that basically means that we're going to add logic to our missiles that is very similar to the targeting logic that we right now have in our ship. So, where is our missile? Good question. Weapons. Missile. There we go. Here's our nice little missile. So, our missile still is nothing more than a box. A rectangle. Yeah, I might at some point change that to an actual missile mesh, but because it's only visible for such a short time, and after that you just, the real visibility is that engine trail. That's actually something we're going to work on too. Maybe we should do that one first. That would actually be kind of neat. Let's do that one first. I actually wanted to try that out. Okay. Because I think that is actually also, as far as showing things off, is actually something new that we haven't done on stream yet. Creating the radar system for our missile. We'll be doing a very quick version of that, but we've already done that for a ship, so we should be able to work through that pretty quickly. But let's do our engine, because last time I did look at the particle system that we built, but we didn't actually build a particle system. So, you know what? Bye-bye engine. We're going to make our own one here. And the reason I want to make our own one, even though it's going to look very similar to what we just had, is I actually want it to become a trail. So right now this thing spits out the effect straight out the back. But as our missile turns, the whole trail turns with it. It doesn't actually become like a smooth trail that we can see where our missile went, where our missile has been as it moves around. And this is also where our initial velocity is going to become very important, because of the way that this will work. So we're going to have a look at how we're going to do that. All right. So we are going to create a new CPU particles. Now I do have to admit, with this effect, the GPU particles probably would serve us a lot better. But because I'm using the Glass 2 driver that's not available to us, we will see how well this works, how well we're going to be dealing with this. Now, one thing that I forgot is to take note of which. We can still do that. That way. Is that the same way that I'm pointing? No, pointing that way. I see myself in reverse. So remember, we're going into that direction with our. Because we don't want to spit it out the wrong way. So, okay. CPU particles. Let's not move our screen around. All right. So, CPU particles, when you add them, nothing happens. This is something that I bet catches people off guard every time that they use CPU particles. So, I'm actually going to rename this to engine, not engine, engine. There we go. So whenever you add these things, and with the GPU particles it's even worse, because there's much more setup before you actually start seeing something. That does, I think, catch people off guard. So the first step is go to the drawing tab, and here we are going to go and put a quad mesh, and we are going to go and create a spatial material, a material on the quad mesh. Now I was actually expecting our quad meshes to start appearing already. They probably do. Very big. No, they don't. Bedding. Oh, there we go. I'm looking at it the wrong way. So yeah, we still know that we need to go that way. So we have got all our beautiful meshes being thrown out. So we got 8 meshes. So what is happening right now is our mesh is emitted, and it lives for 1 second. So it's going to then start falling, because the default behavior is falling with gravity. So that's why we're seeing them move down. So we're seeing them moving down by default for 1 second, and the moment that the 1 second is up, the particle is destroyed and we emit another particle. Now we have 8 particles in total. So over that 1 second, we are emitting 8 particles. And then the 9th particle is actually using the first particle again. So we have basically 8 meshes at any given time that are being expelled from our missile. So that's an important one to take note of. All right. So we're probably going to up that lifetime in a minute, but I'm going to leave that at 1 for now, just to work with. This is not a one-shot. One-shot is something that you would use if you do an explosion. Okay. Sorry, I just got a message on my phone. Really should turn that silent. Actually, let me quickly react to that one, because that is my missus. Kind of important. Hold on just 1 second, please. There we go. Alrighty. Okay. Where were we? So yeah, so one shot is for explosions. That's something that we might do something with at some point. We have a speed scale that just scales the speed up of all our elements, or all our things. Again, it's not something that we will be playing with right now. Randomness we might play with a little bit. To right now, the particles are all being emitted 8 times, or every 1/8 of a second at a fixed interval. So when you change the randomness, it's going to get some random variation in there, so that it makes it a little bit more organic. The same with the lifetime randomness. Right now, every particle lives for 1 second. So with the lifetime randomness, you can variate that for every particle a little bit. And again, it helps make it a little bit more organic. So there might be things that we are going to play around with. Fixed FPS, just make sure that the animation is on a fixed on a fixed step ratio. Not really quite sure how important that is for what we're doing here. I'm not really sure in what scenario that would really be important, because obviously right now we are controlling our particles based on how fast we're rendering stuff. And that could potentially mean that that if you would play the same animation twice, or the same particle effect twice, each time will look slightly differently depending on how the timing falls. If you want them to be exactly the same, and this can be important if you're reproducing something in a multiplayer game or something like that, you might want to set a fixed FPS. Kind of the same reasoning why the physics system works on a fixed interval instead of on our frame timing. Okay, so we're going to leave that one alone. Fractional delta, I find that actually a very interesting setting as well. I'm not quite sure how you can have a non-fractional delta. Don't know enough about the internals. I find if someone knows what the importance of that setting is, well, I can imagine turning that off. We would get very ugly particle effects. But yeah. All right, local chords. That one is going to be very important to us. Right now, we have got this set as local chords. And if I move my particle emitter around, actually I don't want to move my particle, I actually want to move my whole rocket. You can see that the particles are always in the same place relative to our missile. And that is the way that our engine right now works. And as we are rotating our object around, our whole stream of particles rotates with the object. Oh yeah, that was for our debug stuff that we did. So now, where's the debug material coming from? That's something that we did last time to see our trail of the missile. So when we turn this off and we now do the same, notice how. So the particles are now emitted in global space, and they are moving completely independent of our missile. Cool. And that's what we want, because that gives us the ability that as our missile makes an arc, we can see where the missile was during that arc. But we do need to do a few more things to make that work pretty well, and we'll see how that goes wrong if we don't do those things, and take it from there. So we want that to be off. Now the next thing that we really want is we want to make sure that we can always see our particles. So I'm going back into our material, and we're going to go to parameters, and we're going to say we want this to be a particle billboard. I'm not 100% sure what the difference between a Y billboard and a particle, but I think Y is always, yes, or always aligned with the ground, and a particle billboard is always aligned to the camera. Now, remember what I said before with our targeting and reticle, that a particle billboard on the desktop works really well, but on VR has some illusion issues. I'm not worried with our engine effects because of the way that we are blending them once we are finished with this, and because of their size, the eye doesn't really have, and the fact that this thing is moving through space anyway, that illusion holds. So it's really for things that are static, that are in place, where when we are moving, our eyes are, they latch on to the fact that this billboard moves through space unnaturally. And And again, that only works for VR. If you're on a desktop, because we don't have stereoscopic sight on desktop, it's not a problem. But for something like this, for an engine, even though our brain could potentially pick that up, it's very unlikely because of the sort of effect that we're doing. And it's all got to do with the fact that we're blending the whole shape. So so we're not really seeing these. Well, right now these squares will be really obvious. So right now that illusion would be broken. But of course we're not going to keep this to squares. We're going to do something more fun with this. So I need a drink. I need to refill my drink. Hey, sounds beard. Ooh. Nice of you to join the stream. I hope you are well as well. We're doing great. We're having a lot of fun. We need a drink. Plain water. Forgot to buy some taste for the water. So yeah. Usually I mix a little bit of cordial in there. I like my fuzzy drinks. Anyway, so obviously our particles are dropping right now. We're gonna leave them dropping. We're gonna make something work much more fun with that in a minute. Because first, we really want to set up our material first. So the next thing that we need to do is in our albedo is we need to set up the image that we are going to display. Now I am going to use the same image that I'm using for our engine, which should just be a misc here, which is just a an image that I created in Krita. All that this image is a an image where we are changing the alpha of this image, this radial thing, from 1 all the way to 0 to on the outside edge. Now it's currently rendering it as a single gray thing because this is currently not a transparent material, and therefore that alpha channel is completely ignored, and we just get the outer ring of our circle that's being drawn here. There's a little bit of noise in there, but that's fine now for our engine. Now, another shape that you very often see used here, and that's something that we'll start using for explosions at some point in time. Right now, I think I'm using this one for the explosions as well. It's not the best shape for that sort of stuff, but it's like a smoke image or something like that. But these generally, the best thing that works for these things is a grayscale image that goes from black to white. In hindsight, seeing how we're using this for a particle, I shouldn't actually have used the alpha. I should have just made this a normal grayscale image. Anyway, the reason also why you want a grayscale image is because we're going to control the color in our particle system. And white is a really nice color to multiply another color with to change the color of our object. We don't have to do any sort of hue shifting or something like that. We just multiply a color with white. I can actually very quickly demonstrate that. I can change that to red, and all of a sudden we have a red particle that is being ejected. So we are going to leave that guy, I kind of close this, that guy to white. So we're going to use white, but we are going to go and turn this guy on, use as albedo. Now nothing changes right now. All we're doing here is we're going to be outputting a color from our particle system, and by ticking this tick box, that color is now going to be used as the albedo input of a rendering, which actually means that that one is now being ignored. That's going to be overruled by the color that we are going to be giving our material when it's rendered. All right. So we need to do a few more settings here to start to clean this up. Well, one is we want to make that guy transparent, so now we can see that we actually have these circle objects that we are dropping off that sort of fade out to the edge. And I also want to make sure that it's unshaded. You know, this is our engine trail. It actually emits light when it's going straight out of our engine, so we're not going to be affected by the lighting of our scene. So we want it unshaded. We want to take that all out. But the real magic when we are doing a particle system for an engine effect or an explosion effect or anything that is emitting light is that you want to change the blend mode. So the blend mode is currently set to mix, and that means that the color of the particle is mixed with whatever color is behind that particle. And that means that if we have two of these laying on top, it might brighten slightly depending on what was behind it. Basically, we don't get anything. So what we actually want to do is we want to make the blend mode additive. And that means that our color that we're drawing is added on top of what was already there. So the more particles that are overlaid, and I'm going to just simulate that by upping the number of particles that we are going to emit. So let's say that I up a lot more. You can see how that becomes one big white stream because we're adding all those colors together. While if we only have one particle, we see that the particle is just drawn as is. Now, interestingly enough, if I wasn't using my alpha channel, but I was just using a map that is going from white to black, I don't even need to make it a transparent object, because when you add black, nothing gets added. Black is no color, so it becomes quote-unquote transparent by default. So let's go back to 8 particles, which again is way too little, because that's how we get our additive effect to to start showing. Actually, I probably want to have a little bit more. I'm going to go for 15. There we go, because I want that overlap to be a little bit clearer right now, because that really gives us that inside effect for our engine. There we go. Cool. All right. We'll be tweaking that a lot more in a minute. Actually, I probably want to tweak that already a bit. By the way, the other reason why I'm letting them drop, even though that's obviously not the effect that we want, right now it's being controlled by gravity. There is no gravity in space, so we're going to remove that. We're actually going to shoot our particles out at a certain speed. The reason why I am letting them drop right now is that therefore because we don't have that speed set up yet, it gives us a way to work with how this looks. Now, I want the lifetime of the smoke to be a bit longer, so I'm actually going to make it 5 seconds, which is much more than our engine works, and we can really see the individual particles right now. But that creates the length of our trail. Now, 5 might turn out to be too much, but it also means that we need a lot more particles to start getting a proper trail. So let's keep it to 50 and leave it dropping out like this. And again, if we move, we can see that those particles really start to fall out in weird places. Oh, that's not... Now we went one too far. There we go. Okay. So yeah, like I said, I'm going to use the fact that the particles drop to give us a little bit of control over our effects. Or shall we change the direction first? I think we're going to change the direction first. So let's go down our list of things that we need to set up. So I don't care actually about our material anymore. I think we've got everything set up. I do want to keep scale. That's going to be very important because we're going to scale our particles. If we don't do that, our particles always stay the same size. We don't want that. We actually want our particles to change a bit of scale as they fall. But I think everything else here can remain the way that it is. I don't think there's anything else that we want to do here. So we can leave our material alone. That's all fine. All right. So we're done with that one. Our emission shape defines on how our particles are emitted. And right now they are emitted from a point in space. That's why it's at the point. But we can do a sphere, which means that we randomly emit our particles within the confines of a sphere. So instead of them all being emitted from the same place, they're emitted somewhere within that sphere. Same with box, they're emitted somewhere inside of the box at a random position. Points is an array of points, so instead of everything being emitted from one point, you can specify a couple of points that you want them emitted from. And directed points means that you could have every particle emitted in a different direction for those points that we specify. But in our case, we're more than happy with a single point, which also means that we do not care about these arrays. We are not going to be using those. We're not going to care about the flags. It's not something that we're going to do with. And this is the direction at which we are emitting our particles. Now, right now, we're just emitting the particle. It doesn't get any velocity, any speed, and it just falls down. So these settings currently don't do anything for us. We're going to come back to those in a minute, because right now, our particles are being moved by gravity. There is no gravity in space. And now our particles still stay in the same place. So, our particles need to have a velocity. Now you can see that in this case, our velocity is not a vector. It's a speed. So if we give that a velocity of 1, we can see that our particles are being emitted at a speed of 1 unit per second. And whatever unit is, in our case, a unit is 1 meter. So they are being emitted at the speed of 1 unit per second. And we can immediately see a couple of problems. One is we're now pushing them out sideways, while we need to get them to go out the back of our thing. The other thing is we get this big cone. So first, to get them into the right direction, we need to change those. No, 1. No, it is -1. There we go. So now they are being emitted out the back of our missile. But that cone that we are creating right now, the fact that they are randomly being emitted in a certain direction, is set by this 45 degrees. And it's actually exactly the same as our radar logic that we created before. Is, the wider that angle, the bigger that cone becomes. So we want that one to be really, really, really small. And that is pushing them out the back like so. And we're going to go and move that over there. And there we go. We have our particles being emitted at a nice constant speed out the back of our missile. Now, whether this velocity is the right velocity, we will soon see. We'll really not know that too well until we see our missile in action. I wouldn't actually be surprised if the best will actually be 0, because our missile will be moving, and that will create our trail. Or we might actually make them move in the direction that we're flying. That's something that we need to start playing around with as our missile starts flying. And that's the bit of experimentation that we'll need to do. That also means that this speed might be too low. We will see. In order for us to properly start seeing how this effect will work in game. All right, so let's make this actually look like an engine flame, because right now it's just one big white blob. So we're not going to worry about our angular velocity. We're not going to be worried at all about accelerating our particles. We don't need any acceleration. Same with radial. The same with tangible. So radial is, I think, in the direction that they're being emitted, so that if you're emitting a particle like that, they could be, moving up or down or whatever you want. While tangential is around its axis, so you can do some fun thing with that. Damping is how much our particle slows down as it's being ejected. Again, we're not going to worry about that at all. Angle, so that's a variation of that angle at which they're being emitted, so we're not going to worry about that. We are going to worry about the scale, but we're not going to start there. We are actually going to start with our color. So we don't actually want our particles to be emitted in white. We want to change the color of our particles over time. Now, the idea here is the theory about how a flame works. When a flame, an engine, anything, it's a gas being ignited, or it's some substance being ignited, creating a gas. That gas is super hot when it's expelled from the engine or the flame or the match or whatever you're burning. It starts really hot. gets expelled out, and it starts to cool and cool and cool until it's cold. And that temperature of the particle of the gas being emitted changes the color of that gas from emitting a bright yellow or bluish color, depending on what or green can even. If you can burn copper, it'll be green. And as it cools, it turns to red. It eventually turns to gray. It turns to black, and it becomes smoke. Now, when you look at that sort of thing, these particles, you know, you're talking about molecules, right? You're talking about very tiny things and millions and millions and millions of them as this gas gets expelled out of the engine. Well, we're not doing millions and millions and millions of particles. We're doing 50 particles right now. So our shape is actually being that representing one blob of gas particles that are being expelled out of our engine. And because one blob of gas particles, or all the particles that are emitted around the same time, they'll be at the same temperature, they'll have the same color. That's why we can do this, and it actually looks realistic. So we're going to make that work, and we're going to do that by creating a gradient. Now we're seeing immediately that we're getting the exact opposite result of what we want. We're getting something that starts completely invisible and then becomes really, really white. And that's because our default gradient goes from black to white. So we're now expelling black particles, and we're over time changing those particles to white. That's not what we want to do. We actually want to start our particles at a color that they are being expelled at. So we're going to start with blue, a nice blue center of our flame, and we eventually want our particles to end up completely dark black. So now we can see that we've got our particles starting at blue and then nicely fading out to black. There we go. So that already makes it look like a pretty interesting looking, very bluish tail. And you can again see that as these things are drawn overlapping, they really start to turn to white as they oversaturate, because all those particles are drawn on top of each other. They're all additive, and they really start to create that core flame effect when you look on them dead on. So that's a pretty cool thing to do. This is one bug in this interface that I really don't like, is I didn't touch anything, and all of a sudden it decides that it wants to move that color. So Godot has its interesting little things. I'm gonna create one more point here because I actually want that to go to white, and that's eventually going to allow us to get that smoky effect. So you can see that we're now going from blue. Well, I don't want that bright white here because I actually want that to be the smoke effect, but we'll see that in a minute. We'll get that to work a little bit better. Here's that bug again, but I also want to introduce a bit of a reddish color in here, and we need to play a little bit about the positioning of that thing. There we go. And this is always a bit of experimentation with the colors that we're using. I'm wondering if I should be doing that the other way around. Hang on for a second. Let's see, images. I'm not quite sure why it's doing that in there, but anyway. Flame. No, not flame. Flame. There we go. So here we can actually see that this flame is starting with red. There's a bit of a bluish around it. Let's see flame particles. I just want to see if there is a good example of what color gradients would be nice to use. Gradient. Nah, it's just doing. Oh, well. I should probably do a little bit more research in which way around I want to do that. So can we just flip that around? I just want to see what that does as an effect. So I think that the color change is too drastic here. I do like how it really shows like more like a burning color. Come on, something else. Like a burning color here. Come on, I want to edit you. So you can see that how the more white we get into there, the more we get that hot streak inside. The more we go towards yellow, it gets brighter. So kind of like that. I might want to do a little bit more of this as well. So we're going to make that trail go much longer. Actually, let's see if we can get the speed up a little bit more to get a much longer trail. Because it's going to be a bit more realistic of how it's going to be in game. Because this is going to be a much longer trail in game. So you can see that when we stop having overlap on our particles, because we don't have enough particles coming out of our engine now, you can see that that real bright effect of the flame is getting lost. Uses the lightsaber. Yeah, you can do some really cool things with doing this, sizing the particles the right way around and stuff like that. Okay. So probably at this speed, we're going to need a lot more than 50 particles. And that's something that we're going to have to see where that balance lies. But I don't think we can do that until we really start getting this thing in game and start seeing how the trail behaves. And we'll have to tweak this a little bit more. All right. So the other thing that I really don't like that problem. Okay, let's put them in there. So yeah, we'll keep it like that just for now. And we'll play around with that a little more. So I also want to start playing around with the scale of our particles. And for that, I'm going to add a curve so that we can change the scale of our particles over time. This does start off with not having anything set, which is why all our particles have disappeared. So we're going to say that our maximum value is that we want to be able to scale it up by 2. And our minimum value, we want to do half. So I don't want to make it any smaller than half. And again, this is going to be our scale at the start of the lifetime of a particle, when it's emitted at the missile end. And over time, over those 5 seconds that we're keeping our particle alive. Oh, hello. Someone open the door. That's going to be the scale at which we end. So we obviously want to go and create a point here. We're actually going to make that, we're going to make them start a bit bigger. We're going to add a point here. I'm going to make them go smaller. So that gives us that effect. But actually, once they start getting smoky, and for that, I actually want to get this one more back. So like this. And I might actually want to make those a little bit more pronounced, so that as our particles really cool down, they become like smoke particles. Yeah, come on. So we're going to want to go, and again, this is our time for a color. We've got the same timeline over here, so that's going to be matching up pretty well. We're going to go and make it go a bit more like that. But then here we want to go and start making them go bigger again. Let's see. And here I actually want to go all the way to 2. I'm wondering if I shouldn't allow even a bigger scale there. Let's see if we go all the way up to 3. There we go. I think for something like that, we might even want to start that earlier. I actually might want to go and remove this point. It becomes more important that this becomes a little darker. Because of course, you know, once it cools down, it becomes smoke. It starts to sort of bellow out a bit. Just really what I wanted to try and reproduce here. Let's go and put that blue a little bit closer to the start of the flame. All right, there we go. Cool. Okay, now I'm gonna do something crazy just to start with. And that is that I'm going to make, actually if I make this higher, does it also speed it up? No, I think it normalizes that, so that's not gonna do anything. So that's 1, okay. Put it at 0. I'm gonna start putting this at 0 because I want to see what happens if we just have the trail as we fire our missile through. Okay, unsigned foo. Yeah, you can do some really cool things with it. In Glass 3, the particle systems obviously work with HDR. The HDR is just your color range that we're working with. And the moment that you're in the Glass 3 renderer, all the 3D rendering is done at what is it, 16-bit per color instead of the standard 8-bit per color. So you have much more control over your light values. It's actually stored not as an integer between 0 and 255, but it's stored as a floating point, a 16-bit floating point value. So you can actually have light intensity go above 1. And yes, your particles, you have control over that, especially if you're using the GPU particles, and you can start really going to town with doing funky things with your colors. And that obviously, you know, when you do that sort of stuff, it feeds into your glow effects and all that sort of shit, other stuff. You can really really go to town with the whole thing. All right, I just want to see how this effect currently behaves in the headset. And from there we will start knowing how much more we need to tweak this effect. All right, so let's go out of our ship first, and I'm going to target, and I'm just going to sit over here. I'm going to first fire out from standing still. All right, so here we can see how much space there is between. I think we almost got the whole trail. So it took less than 5 seconds for this thing to actually hit. Boom. That's not too bad. So if we're going at speed, let's see what happens now, because now we're going to get some relative speed in our. So now we can really see the spacing. Now, one thing that we can see immediately is that 5 seconds is probably way more than we need. Oh yeah, that's the other thing that's actually kind of cool with that. I made that effect draw on top of anything. So I've actually turned the Z buffer off. And again, this is just to simulate that our targeting is actually superimposed on our, you know, our helmet that we're wearing. So so yeah, I wanted to make sure that even if we're looking through our ship, we are seeing our targeting reticle. Thought that was a nice little touch. Oh, all right, that guy's gone. All right, so I'm actually quite surprised at how well the trail does seem to already start, but we are going to play around with this lifetime. So I'm going to start with changing the lifetime to 2. Just to thinking about Unsigned Foo's question about HDR. So again, we're using the CPU particles here, which are really ended on the Glass 2 value or renderer. So I'm not quite sure if that would actually have intensity values. We'd have to work around with the GPU version of this, whether there is actually a intensity value that we can do. But I think you can control it in your material. So again, you know, this is the Glass 2 renderer, so it will be off. But I think you would start to use your like give it an emissive color, and then you can really up the intensity of the color, and that could really make it bright. Or use a shader instead of a material, right? Inside of a shader, if you use a shader material and you write your own shader, you can, the intensity is just a value of a color above 1. So instead of white being 1.111 for the RGB values, you go 222. You get actually a really bright particle. Now that still renders on screen as white, as 111, but especially in combination with glow effects, it really it starts to have an effect on the on what's around it. But yeah, we would have to start experimenting with the Glass 3 renderer to really really investigate what it is that we want to do there. All right, so I quickly want to have a look at what lifetime 2 is, if we get enough of a trail of what we're doing, but we start getting a much lower gap with our particles. I'm actually not going to put my headset on. I can't remember if I zoomed in just now, which I might not have done. Oops. I did that a little bit too quick. So, because our particles are emitted while we're moving, and but they're, whoa, whoops, thank you. So that's why I just want to stand still for a second. So the spacing is a little bit better. Now we could do more with the size of these particles. I think the trail is... Okay, so the thing that I really wanted to do, just to see if that makes does the trail go a little bit better. And let me think, how are we going to do that? Because I'm wondering if they should get some of the speed of our missile as we're firing our missile, which means that we're constantly in our process function, we're going to be updating that a little bit. Okay. Now the problem that we have is that we have a combination of velocity and direction. So the direction we want to set to the direction of movement, but we have to normalize that, and then we can set the velocity to the velocity of our missile. But now all the particles will stay with our missile. Let's actually do that for fun. It's actually good to see if that works. Okay, so we're gonna leave these in place because I might do something more with that later. Because these are going to be emitted. Actually, you know what? I don't want to calculate this more than once. We're already calculating our delta position here. So no, we do really need to do that in process, because our GPU particles are updated in process. No, we can get away with that because we have our delta function, so we know how fast our particles are moving. It's just that, let's say that we our frame rate drops to, let's say, 45 frames per second, half the frame rate of that we're handling our physics process. We'll be updating our particle information twice and only using it once. Well, it's not gonna do anything. It's not, it's a small calculation, and it's not really gonna have an impact on our performance. So I'm not really too worried about that. This is really where I'm running out of space, though. Yeah, because I want to be able to see that. Yeah, we might increase the amounts a little bit, but I want to tweak a little bit more before we decide to do that. Okay, particle shader material is okay. Again, going too much into GPU particles at the moment. Right now, with our CPU particles, we only have one material. That's a material that we use to render our particles with. And our logic for actually controlling the particles is built into the CPU particles engine. With GPU particles, we have two shaders. We again have the shaders, the normal material shaders with which we render our particles themselves. That's the one that I'm talking about, that you need to play around with upping the intensity. But now we have a new shader called a particle shader. And the particle shader is a compute shader that we can write that controls the behavior of each individual particle. And you can really go to town with those things. Now, I say compute shader, it's actually not really a compute shader. We are, as far as I'm aware, we're actually using a normal shader that renders to a texture that then becomes the input to our actual particle location logic. But it works the same as a compute shader. I'm pretty sure that with the rewrite of particles for Godot 4 to Vulkan, it is going to be fully a compute shader. That does all the logic. But again, the particle shader controls the position of the particles. And the default particle material, the one that you don't actually write a shader for, the normal particle material, implements a version of the CPU particles, but as a shader. Basically what it does. So you have all the options that we're playing around with right now in CPU particles. You have those same options in the particle material, but it's a shader, and you can really go to town with what this thing does. So you have far more control over how the particles behave, which is pretty cool. Which is why I abuse particles to create grass. Yeah. Get creative. All right, so I'm gonna leave that all alone. We're gonna say here we go. Match speed of particles to our missile. Okay, so we need to do that in 2 steps. Okay, what will that be called? Direction, I guess. This is always a bit of the annoyance, is, yeah, direction. So there we go. So that is going to become our delta position dot normalized. I'm just double checking if we're not updating our delta position anywhere. No, we're keeping that the way it is. So now we are emitting our particles not out the back, but we're emitting them in the direction of travel. Sounds really weird that I'm doing that, but there's reason to my madness. The other thing that we want to do is we want to set the velocity. And that's the linear, no. Okay, so we're going to do the same trick here, because I can't remember what the thing is called. No, that's not the initial velocity. No, it is the initial velocity. So I was typing initial. Why doesn't it autocomplete? Oh, I was doing no, I was doing linear velocity. No, initial velocity. So okay. Now this is wrong. I want to make clear we are forgetting something very important. Right? So we're now telling every particle to be emitted in global space. So it's going to not be linked to our missile. But we're giving it the same velocity and direction of travel as our missile is going into. So we're actually going to move in a particular direction. All right? Cool. And we'll see that if we would shoot our missile straight, all the particles would stay with the missile. While we're accelerating the missile, so they will slowly stretch out. And maybe that's actually enough in what we're doing, because we are accelerating the missile. That might be enough to do what we want to do here without having to add a vector in an opposite direction for our particles. We will see. Again, this is just playing around with the variables and trying to find where a good mix lies. Hi, Declan. Yes, I am doing Glass 2 first because the Glass 2 renderer is has a lot less overhead than the Glass 3 renderer because it's doing much simpler work. So purely from a VR point of view, and especially for a space game where our lighting is relatively simple anyway, we don't need a lot of the really cool things that we can do in Glass 3. It doesn't really add to the effect, but it does cost performance. Well, we want to have as high a performance as possible for our headsets because we're rendering at as high possible FPS as possible. Now forget for the fact that when we're in the carrier, that's screwing up. That's because of the carrier, nothing else. What was I saying? But the other reason indeed is, you know, we might eventually see if we can make this run on an Oculus Quest. Probably not in its current form, because we are doing a few things that the Oculus Quest is not going to be very happy with. Especially the old transparent effects that we're playing around with. But, yeah. Alright. So, initially we don't get much of a difference because our missiles... Oh, it's starting to track my headset. Because our missiles starts off standing still. But once the missile starts gaining some speed, it is starting to take effect. Okay. So that is actually not bad. That is actually not bad. I'm trying to think about if I want them to do a little bit more. No. Ha 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 ha. Let's try again, shall we? We made them way too slow. We have to have our velocity in units per second. Our delta position gives the amount of travel over within one physics frame, which is 1/90th. So we were traveling or expelling the particles at 1/90th the speed that we wanted them to be expelled at. So we need to divide them by our delta. I'm actually going to put my headset on for a sec because I really want to see how this looks inside. So tracking is now on. So let's go and get our target lock. And oh, fire. Alright, so now you see that our particles are going all over the place because they are moving along with our... You can also now see how erratic our missile is actually flying. Okay, that's weird. It's going into the wrong direction. It's going sideways. Okay, why would it be going sideways? Okay. We're gonna cheat. Okay. Why would it be doing that? Why would it be doing that? I wonder. This is where it would be nice if we could slow the whole thing down. And see where our particles, which direction our particles are going to. I think. Because if we're moving forward, we should be moving in that direction. We should be expelling them in that direction. That is strange. That is strange. Hold on, I want to try something. Because actually, I think that has got everything to do with the fact that we are... I was shooting them very close to our targets. I think the problem that we're having is when we fire our missile and it needs to correct to go towards our target, it's continuously overcorrecting. That's why our particles are now always being expelled very erratically. And of course, when we get too close, at some point it makes a sharp turn. So now our missile is flying, starting to turn that way, but it's still moving upwards with space because we don't have a lot of drag in there. And that's why I was seeing the particles going sideways. So I think that was mostly just an illusion. So I don't think this is actually a good idea, because even if we slow them down, I think our process will just be too erratic. So I think I liked it better. I'm just going to comment it out. I might play around with that some more and see if I can figure out if we can make that work a little bit more different. Okay. Now, I'm not quite sure how much particles we can handle without this thing getting overloaded. Because again, CPU particles are slower than GPU particles, but I don't know where we're going to start seeing a detrimental impact of this. Because of course, the more particles we emit, the better the effect will be. We're going to go and I'm going to make them come out a bit. Let's just see how well that works, because I do want them to move a little bit at some speed to see if we can get them out. Too much wind in space. How to use shader instance? Yeah, basically the idea is that in your material you set which colors you want to use, which textures you want to use, and all that sort of thing. So you would generally reuse the same shader if. Oh, and this basically what Godot does internally as well. If you create a material instance and you set up the same settings and options between two different shader or spatial materials, if the options are the same, it creates the same shader script. It will actually just have one shader, or reuse the same shader as the other one. It's when that changes, if you change one of the options that creates a new shader, that's where things start to get really messy. That's also what causes things to have hiccups and stuff like that. Hold on, I just want to go and make sure that's not rendering anything. So yeah, generally when you're using shader materials, if the shader doesn't change, you would save the shader into a separate file, which is always a good idea, by the way. We always recommend doing that when using shaders. Why am I still moving? Come on, slow down. And then you set up multiple materials that use the same shader, but then in the materials you change the texture that you use or the color that you use or things like that, depending on what your need is. Yeah. Yep. Let's go. That's outside of my ship. There we go. I hope you guys aren't getting too bored with the beeping sound. I hope I turned down the volume on that enough. Okay, so that actually looks pretty well. So with a lot more, so when I go and shoot from a little bit further away with a little bit more speed. So let's go back to our, oh, I overcorrected my spin a little bit too much there. Alrighty, here we go. Let's lock on again, and we shoot. Yeah, that looks pretty cool actually. I like that. Oh, what an overshot. Yeah. That's actually a pretty neat effect. Oh, and we fired our missile without actually having a lock. And do that again. Alright. I think we are getting pretty close to an effect that is pretty much what we want. Now, okay. I'm going to go one higher. I'm going to go to 150. Because it didn't really look like we had any noticeable impact on our performance. Hour of time. I got about half an hour left. I can probably go a little bit longer. Because I do want to have, you know, I do want to set up that fire and forget sort of logic for the missiles. There we go. Maybe I should make it a little bit less than 5 seconds. Bang. Oh, and it overshoots. So that overshooting is actually something that we need to start dealing with as well. Yeah. Now, obviously, when we're too close to our enemy fighter, then the overshoot is pretty logical. But when we're... Whoa! What happened? Okay, I'm not quite sure what happened there, but it suddenly had a big hiccup. That was actually, I think, in my headset, not actually the game. So I'm not quite sure what happened there. Might have been something on my computer that suddenly decided to give a halt on things. Alright. We're still not out of missiles, so let's keep firing a couple more. Alright, these two guys overshot again. Oh, yeah. Oh, and they missed. Alright. They are going faster and faster and faster too, so, and they're at the end of their life. Okay. All in all, that is pretty cool because we can really follow where the missiles are going, and that's actually, I think, something that's going to be really cool when the missiles get shot at us. I wasn't really paying too much attention to what the frame rate was doing. I would assume that this number of particles shouldn't be a problem because they are likely being drawn in a single draw call. But it is obviously communicating 150 positions every frame because it's being calculated on the CPU and then pushed out to the GPU. So I really don't know where the limits of this is. You know, I know that the GPU version of this would have absolutely no problems with. We could have. You know, I think I used a GPU one in my weapons tutorial for the really overdone smoke trail when we did our little handgun. And I think I was doing a couple of thousand particles for that one. So I might be being too conservative. I don't know. But I like the fact, you know, because I was thinking that we needed to speed up our particles to keep them, you know, sort of moving along with our missile, but with some amount of freedom, especially because we ourselves are moving so fast through space. But actually, it works really well. I'm quite happy about that. So I think we're gonna leave our trail as is. I'm thinking, well, maybe actually, you know what? I'm going to up this a little bit. I just want to see what happens if we up this. Obviously, here it is going really nuts. I wish we could scale this view up a little bit so that we can see a little bit better what it's doing. Okay, one final run to see what my tweaking was doing. Particles are indeed disappearing when the rocket is destroyed. That's because we have this as a child of the missile. So I'm not going to worry about that too much right now. Basically, what that means is what we want to do is delay destroying the missile. So we're going to... Oh, actually, we might actually quickly implement that. Why not? It shouldn't take too long to add that in. Here we go. Okay. Oh, I forgot to target first. Okay, there we can see that when we're looking straight ahead at our missile, it does go a little bit nutsy. I actually want them to overshoot now. Of course, when I want them to overshoot, they're not going to overshoot. Okay, that one might be overshooting now. There we go, that one's still going. Okay, that's pretty funny. I think I overdid it a little bit on the size here. So let's bring it back a little bit. All right. Actually, I might want to move that up a little bit so that it doesn't get that small. Now, I bet you if I move that down to 5, I destroyed my line. Oh, no, that worked pretty well. Okay, cool. Okay, let's make sure that our smoke trail doesn't get destroyed right away. So we got a lifetime timer here. Okay. And I think we're going to do the same thing when we hit something. Okay, that is, of course, being handled here. So we have on our lifetime timeout, we are going to do a queue free. And when we hit something, we do a queue free. So what we're going to change here is we're going to make a new function. We're going to call it die. And on our die, we're going to go and call our queue free. And that means that our default logic is that's what we're doing. We're just going to queue free. So for all our existing lasers and stuff like that, when we hit, we die. Now, for our lasers, that makes sense. But for instance, for our bullets, we might actually also do something here that we don't actually kill it off right away. We might do a different effect. But I wanted to make sure that we have a method here that we can override in our script. So when we look at our missile script, we're going to go and we're going to overrule our die function. So let's create a new function here called func die. And what we're going to do here is a couple of things. So looking at our missile, we want to, so our missile is a rigid body. Why am I seeing my whole debug? Here we go. Is a rigid body, so we're going to take that out of our evaluation. So we want to, oh, it's already not in a layer. We're going to turn the layer off. We're going to take our mask off. So we're going to say collision layer. It's going to be 0, so it's no longer in a collision layer. Our mask is going to be 0, and our mode is static. So that stops our missile from moving. All right. Now at our engine, we are going to say that we are going to stop emitting. So that is slowly going to make our smoke trail end its animation. So that's going to stop our engine from working. Now we don't have something here that allows us to get a signal when our engine finishes. So I don't want to reuse my lifetime timer for that. So we're just going to add a new timer here. Free timer. Thing needs a name. All right. That's going to become a one-shot. It's not going to be auto time. I'm going to leave the wait time to 1. And instead, what we're going to be doing, we actually need to have that hooked up. Timeouts. There we go. So on this timeout, we're now going to say queue free. So we've overruled our die function, so our queue free is no longer being called. We're going to queue free when this timer runs out instead. And that means that over here, we want to say that we're going to start this timer, and we're going to actually give it our lifetime value. So our lifetime, if we decide to change that, so let's say that we change that to 2 seconds or 3 seconds. Now, when we stop emitting, that's when our last particle gets emitted, that particle will still have a lifetime of whatever we've got it set. So say 2 seconds. After those 2 seconds pass, we know that all the particles have been dealt with. They've all been faded out. That's when we can delete our smoke trail. So let's see if we did the right thing or made a mistake. Hello, Arthur. Welcome. Glad you could join us. All right, let's see if we've done the right thing here. So I want to get a bit closer so we can see when we hit our target whether our particles nicely fade out. Boom, there we go. So now we see that our particles aren't immediately disappearing. They are slowly fading out. And we overshot again. Alright, so the overshooting is not something that I'm going to fix tonight. But basically the reason why we're overshooting is our missile is traveling at a certain speed. And we've programmed it to try and steer towards our enemy. But because it still has a momentum, because it has a forward motion, it's going to move beyond where the target is. So it's always going to overshoot it if it has to make a sharp turn towards the enemy. Now, once our enemy starts moving, starts flying, which I don't think we're going to have enough time for anymore tonight. Once our enemy starts moving, then obviously that is going to be less of a problem because our enemy is actually going to fly into the trail of our missile, especially when it needs to make a sharp turn. When it's going from behind, it's going to follow it pretty nicely, I think. But we really should be adding 2 bits of logic into our missiles to make it really deadly and really on target. The first is it needs to counter its own momentum. So it needs to look at how fast it's moving, and therefore correcting for that by oversteering basically to more to the back of our enemy. And at the same time, if our enemy is moving forward at a certain speed, it needs to actually move its target forward. So we're going to start playing with the target position. Instead of targeting the center of our enemy, we're going to move that target back depending on our speed of our missile. And we're going to move it forward depending on the speed of the enemy. And we should get a position that our missile is going to be attempting to steer towards, and that should mean that it's going to hit the enemies much more accurately and much more often. But that's not something we're going to go into tonight. So I think as far as experimenting with our smoke trail, I think this is enough for playing around with it. There's a lot of room for tweaking and making it nicer, maybe seeing if we can up the count of particles even more, play around more with the sizes of the particles as they change over time to get maybe a little bit more of a smoke effect at the end. Although I actually kind of like how they are right now. They might be a little bit bigger when they're emitted. We will see. But I think for tonight, that is more than enough to play around with that smoke trail. And really is pretty cool that we can now follow where the missiles are flying. And I think especially once missiles are going to be starting to be flying at us, it's going to be very interesting. Now, again, when we suddenly have 10, 15, 20 missiles flying around and we have all these particles emitting, it's going to be interesting to see what that does to performance. And we might need to tweak that some more. And maybe make that even variable, variate the lifetime of the particles depending on how fast your processor is or something like that, or how many missiles are flying around. We will see. They're all the sort of things that we just need to play around with, and until we're much further along with our game, we're not going to worry too much about that. So the last thing that I want to quickly see how far we can get tonight, because I do have a hard out at no later than 12:30. Is looking at making our missiles target lock themselves. And seeing that we've already built it for our fighter, we kind of know what it is that we need to do here. And we start with creating a new area, which is going to be our radar. we go. And we're going to add a sphere to that. No, a collision shape that needs a sphere to that. It's getting late, getting tired. Here we go. Now, the radar on our plane currently looks 2 kilometers ahead. And obviously, if we make the radar of our missile smaller, we're going to have a problem. Because we would be able to get a target lock within the 2 kilometer range. And maybe we need to limit that. That's something to look at. Although I kind of like, for missiles, I kind of like that long target lock. So we're going to be copying that here for now. So we're going to give that missiles radar a 2K range as well. All right. Now, the other thing which is going to be important is that our collision, this is not going to be a layer. We're purely going to be working with the collision mask. Do we already have a ready here? No, we don't. Okay, so we're going to do that on our set initial velocity. And the reason we're going to do it there is if we look at our weapon script. Where is our weapon script? Here we go. If you look at our fire logic, we get our new projectile. Actually, we're adding them here. I think at this point, we could do it. Because we need that mask. And we need to copy that mask into our radar as well. Because we're going to detect on the same things here. Probably not. No, we're going to go and copy this. Can we? Can we? Because we don't want to target asteroids. We only want to go for the right targets, which really is these 3 flags. So that's our player layer, that's our friendly layer, and that's our enemy layer. Let's do that. Okay. So the last thing that we call here is our set initial velocity. So I think that's where we're going to do this, because we want to do it as late as possible in the process. And I don't want to add another method to work with, because normally we do something like this in the ready function, but I'm not sure if our ready is going to be called before we set this or after we set this. So I want to be a bit careful with that. Ready might be called already after we instantiate, in which case we could react on the add child, which is our entry, maybe. I don't want to worry too much about it, so we're going to do it here. Also set our radar collision mask. So that's going to be radar collision mask equals. That's going to start with our collision mask here, and now we're going to do a bit mask. That's a good one. That is a good one. Hold on. Weapon. I'm doing this mask the wrong way around. And I think I got lucky with it working. This mask is in reverse order. I did that wrong all this time. I've got these bit masks the wrong way around. How good is that? All right. Because they work in opposite order. So that's the rightmost bit working from right to left. So That's funky. So I wanted it to have 10. All right, so let's fix that up because that is absolutely wrong. So this needs to be in the exact opposite way. So 0, 0, 1, 1. So that's actually no. Is that yeah 0, 0, 1, 1, 1, 1, 1, 1, 0, 0. So that was actually by accident the right way around, and that's why it worked. That's just pure dumb luck. Because again, we're going from right to left. So this is, let's actually go and put that here. Hold on. Because we're going to go and so this is bit 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C. All right. So that's our layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, etc., etc., etc. So we got really lucky that these are actually mirrors of each other. So I don't need to keep this. But this one's the wrong way around. So this one should still be 0, 0, 1, 1. But that needs to be 1, 1, 0. So this one needs to be like that. Okay, cool. And now we want to go like that. So that one just needs to be 7. Actually, we can just do with 7. So 7 is bit 1, 1, 1, 1. And because we're only interested in the last, or actually the first 4 layers, that will actually we're only interested in the first 3 layers. That will ignore all the other collisions. So that should disable our checking for asteroids and stuff like that. So our radar should only be picking up the targets that we actually want to pick up. All right. Cool. Okay. All right. So we're actually not going to do that in our physics process, are we? So look at our plane. How are we doing it here? We are doing that all in process. Cool. Sweet. All right. So here now I do want to start enabling our process. And we're going to start with, is this a tool script? This is not a tool script. We're safe. Cool. So in our process, we're going to get all the objects that are currently within our radar. And we're doing that every frame. So luckily, that doesn't cost us anything because our area is keeping track of that. It's keeping an internal list of every object within our collision mass that is within our radar area. So we now know what is in there. So if we have a target, that's someone that we're using, right? Yep. If we have a target, we want to make sure that of 2 things. First of all, is our target still inside of our radar sphere? But the second thing is if we are still facing enough towards that target. So, because when we can no longer see our target, we're not actually going to have a radar that's going to look all the way around the missile. We're going to have a radar that's only looking forward to a certain sweep. And again, for our target lock, it's that 45-degree sweep. We're probably going to increase that a little bit for losing our target lock. Might actually on the onboard target lock on our missile, we might even go a little narrower. So what we're going to be doing is if overlapping. Can we do has? Yep, we can. Has target. So can we still find our target in our in our array. If we can't, we're going to say, sorry, we no longer have a target. We've lost our target lock. Now, next frame, we're going to try and reacquire a target. When we lose target lock, we're going to leave that alone for a second. All right. So what we also want to do here is a var target lock. Actually, we call that locked on. I think that's the same name that I... No, that's not bool. That's going to be float, and that's going to be 1 by... Actually, that's going to be -1 by default. But we're going to make it, if we have a target... So this is what we set when we shoot our missile. We're going to assume that we have a full target lock. All right. I just want to have a look at our plain scripts, because we're going to do something very similar that we have here. So let's lock angle, lock duration. Here's our lock value itself. Oh, we just call it target lock. Okay. I want to keep that name the same. So we're right with calling that target lock. Okay. Cool. We want a lock duration, but we're going to make this one a bit faster. So we're going to lock on quicker with the missile, because we're going to be looking in a narrower view to lock on. We're going to give it a faster lock if we can. Then we're going to have our lock angle. So that's going to be cos deck to rad, because I want it to be readable. So we're going to make this one slightly less, 35, just to start with. We're actually going to make these guys export variables. So if we ever decide to make multiple versions of our missile, we might make this our base script, and we might set those things differently. But we want to lose our target lock only within a bigger cone. So we're going to have a wider view. Might actually even make that 60. Just really have to steer away much further in order to lose our target lock. All right. Don't need anything else. We don't need the beep things. So, all right. Export var target lock. Okay. Let's think. All right, so let's first write the logic for losing our target lock, because we now have that logic partially in here. In this case, we're also going to say target lock is -0, so we've lost it now. Very good. Find the closest target. That's what we're going to implement in a minute. So here we now need to say, actually, we're going to need this anyway. So far forward is global transform.basis.z. I want to have that available. Then here I want to go and calculate the direction that we're facing. Actually, can I just quickly copy that from here? So we're getting our global position of our target. We're subtracting our position. So that's going to be our missile's position. And we're taking our origin. Again, if we've already written it, we should reuse it. All right. So here we're actually going to say if it's smaller than, then we're going to lose our target. So, and this actually needs to be our keep angle, because as long as it's within that 60-degree view, we are going to keep our lock. The moment that our enemy flies outside of that 60-degree view, we're going to lose our target lock. Now, this is only in our current situation. This is only going to happen when we overshoot. The moment that we overshoot our missile, we're going to lose tracking of our target because we've now passed it. It's not going to know where our target is. It's going to keep us flying straight. And that basically means that, you know, our missile won't do that big loop around to go back to the target. And again, maybe we won't do that, or, you know, we allow you know, a missile that we have full 360 degrees. We're just going to set it to 180, and that means that even if it passes it, it's always going to keep lock. Once it has lock, it has lock, right? But for now, we're going to limit that just to see if we can lose a target lock. And then it just becomes a missile that keeps going forward until it can't find the new target and it eventually dies. All right. But if we do not have a target lock, we're now going to have to find a target to lock onto. All right. So what we're going to do first is find the closest target that's inside of our lock angle. For that, I do want to go back here. And again, we're just going to copy that logic. It should really do well if we put that actually into something a little better. So we are overlapping. We're going to find all our bodies for closest location. Okay. That one actually should go over here. And we're going to go and move that in here. Yep. Okay. Cool. So we have our closest body is nil. We haven't found one yet. We're going to loop through our bodies. Then obviously in this case we don't care about you because we're only finding the ones that we want to do. So we're going to calculate the distance of this object. If it is closer than the one that we have now found our closest object. However, different here is that we are only going to make this our new target if it also is within our angle. Now, I could do the angle check first and then do the distance check, but I'm doing the other way around because the distance check is less of a problem than the... Actually, does it matter? You know what? We're gonna do both. So we're actually gonna get our target there. I'm actually not gonna normalize that because this obviously becomes our body. Then I can use that here. Again, this is just trying to be efficient with what we're doing. We don't want to do calculations double, just is a waste of time. So here we're gonna say if the distance is smaller than the closest distance, and it's forward dot, isn't it? Yeah. Forward dot target there normalized. There we go. And this one is then bigger to lock angle. So we're gonna check both at the same time. It has to be closest. and it has to be within our angle. So only then we find a potential target. All right. Cool. So for this, we do need to have a new variable to track that. Potential. Let's call that potential target. Body. Boom. All right. Cool. So if we found the closest body, then we are going to go and try and get a lock. So here we're now going to say if target lock is -1, so we haven't tried to do a target lock, or closest body is not equal to our potential target. So we've changed the target that we're currently looking at. In that case, we are going to say our target lock is 0, so we're going to restart it. Else, we're going to say target lock is clamp, target lock plus delta defined by lock duration, and clamp that between 0 and 1. There we go. So we're going to increase our lock timer. Cool. Okay, in both cases, yep. We obviously want to copy this. It might already be the right one, but we need to make sure we do that. Okay. And now we're going to add if target lock. If we found it, we're going to make our target our potential target. And now we have a target lock. If we couldn't find the closest one, we're obviously going to go and make that null. And we're going to say our target lock is going to be -1. So we're going to reset our target locking. So in theory, we should now have our logic that we're going to try and lock our missile onto target when we fire it, when it doesn't actually have a target. Cool. Let's see if we made any mistakes. So this is basically a variant of the logic that we already have for our ship itself. I just want to go be outside of my carrier. All right. Okay, is that good? Yeah, there we go. It's suddenly locked on. I actually didn't have to do that initial lock. So there we go. That's got fired. So if I fire another missile, there we go. So it flies straight ahead for a little while, and all of a sudden it decides I have a target lock. Boom. So, boom. Fire another one. And it's found a target. Now that one I shot too late. So that is already before it gets into the ability to actually lock on a target. It is already outside of that targeting cone, and it will never get one. That's also because we are too close. And this is even with this one. Well, that one got kind of lucky. But again, you know, now it found a target, but it wasn't able to steer towards the target in time. It was already going too fast in the wrong direction. The moment that it got out, it lost target. Instead of doing that big loop that we did before, loses target lock, it keeps going on straight ahead. Do you have any more missiles left? Still have one. And that one just nicely hits our target. So, I'm out of missiles. Cool. Alright, so now we have fire and forget style missiles. Now again, like I said before, we're dumping all the logic that we have into our missiles right now. Well, we're really talking about potentially 3 types of different missiles: heat-seeking, normal radar-based, and fire and forget. So this has now become a fire and forget missile. It doesn't require us to target lock. Obviously, if we do target lock, that means that immediately as we fire it off, it goes after the target that we're currently locked on, which makes it more accurate. While if we just do fire and forget, it takes 2 seconds of it flying before it gets there. Now, because we made the ship 5 seconds and the missile 2 seconds, that means that if we're facing the enemy, it's actually smarter at this point in time to just fire and forget the missile. Now, that said, and that's one of the reasons why I made these export variables, is we actually want to start switching around which missiles can do what. So if we don't actually want our missiles to be able to target lock, we might set our lock target to 0, in which case we will never lock target. We no longer are a fire and forget missile. The other thing that we need to do is for our heat-seeking missiles, we shouldn't just check whether we're still in view of our enemy. We also need to see what the enemy's direction is compared to our direction. So we should be comparing the forward-facing vector of our enemy with our hold on a second. With our forward facing vector of our missile, and when they are still pointing somewhat in the same direction, we keep following. But if we are flying towards the front of our enemy, we actually want to lose our lock, because heat-seeking missiles are targeting the engines, we won't be seeing the engine one. So we would lose lock. Now, the other thing that we could do at that point in time, and that's where is the logic that we just wrote? Where the logic that we just put together over here becomes interesting, that if we do have a target lock, we're currently not checking for anything else right now. So even if another target is closer to us, we won't switch over to that. We are following the target that we have locked onto, and we're going to keep that lock. But for a heat-seeking missile, you want to be able to distract that missile with flares. So when the target emits a flare, and that flare becomes the closer target and becomes way brighter than the target, we should actually overrule it and start making our missile go towards the flare instead of our target. So it's a good possibility, or it's a good option, to actually always do this. And then in here say, if our closest body is still our target, then we just keep it. But if our closest body becomes something else, we have to reacquire a lock, or the lock automatically changes because of the way we work. So that is a possible improvement on the logic that we have here. That's not something that I want to go into tonight, because both of those options, looking at flares for heat-seeking missiles or chaff for radar missiles, we aren't emitting those from our enemies yet. We're not emitting those from our friendly players yet. So adding that logic in, this isn't the right time for it. We need to be much further along with our game. And the same thing for our losing our lock if our heat-seeking missiles aren't chasing the backside of an enemy, but are facing the front of an enemy. That is obviously also a something that we can't do until our enemies start moving. Now, I wanted to start looking into that tonight, but we are starting to get to a point where we need to round things off. So that is definitely something that I think we are going to start looking at next stream. What I want to do with our enemies is give them a really, really simple AI to start off with. when they are not aware of our player, they're just going to follow a set course that we set out. So they're just going to be following a path that we create for them, and they're just going to fly around that path in loops. But when they start detecting our player, and we're going to again do something very similar to what we're doing here. So I need to start looking at actually putting some of this radar logic in a class of itself. So I'm actually thinking about this combo, radar and collision shape, which we also have on our plane, to make that actually a separate component with then our closest logic implemented in there. And again, with probably our targeting vector in there as well, so that we have that logic in one place and we can reuse it, because there's lots of places where this is going to be important. It's important on our missiles, it is important for our player, it's important for our enemies to drive the AI of the enemies. So the moment that our enemy detects us, it's going to get a new state and it's going to start chasing us. When it no longer detects us, it's going to fly back to its assigned route and it will follow that assigned route. So that is going to be our first basic AI that we're going to start working on, and that's I think going to be the topic for next week. So yeah, hope you guys enjoyed what we were doing so far. I think we've made some really interesting improvements here in our missile trails, that we can really see where our missiles are going. And making our missiles a lot smarter, that they can actually target onto enemies themselves. So yeah, some good steps forward, I would say. So as always, I'm gonna have a look at chat to see if there's anything that I've missed, and if you guys have anything more to ask or add to this, please start adding some things in chat. Also, we're going to slowly start putting an end to tonight's stream. Yeah, so that was all about the trails, which were done. What did I do finally, Unsigned Foo? I'm not emitting the particles at any speed. They are going to be placed wherever the missile is the moment that the particle is emitted, and they're going to stay there, and that's all. So we really just see the trail of the missile in smoke. Obviously, they are animated at that point in time, changing color, changing size. Probably will be doing a little bit more of that, and I just upped the number of particles that we emitted. Add monsters as tall as a planet. That can be scary. Might be a good end boss. I wouldn't be against that, Okay, actually, I could spend probably 15 minutes with that. I'm actually thinking about making this logic. We're actually going to go and put our radar into a separate entity. I think that's actually a really good idea. So when we look at our plane, is it here? Yeah, we've got our radar in our plane with our mask there. Yeah, I think that's going to be making lots of sense if we are going to go and so yeah, we're going to start doing that from our missile. I actually want to go and add a spatial in here. Let me call that one. Oh, we're not actually going to call that anything. Move that over there. We're going to call that one the radar. I'm going to call that radar area. Obviously, our script is not broken. And we're going to save this. And I think that is probably a good place to put that. No. Oops, did I click on that by accident? Ooh, almost lost some code there. There we go. Okay. So we now have a beautiful radar. Cool. So we're going to go and add a script here. There we go. So I made this a spatial because I want to hide all the details of how the radar works. We're going to give this thing a range. So we had a range of 200. Okay, we're going to make that radar range because range is a reserved word. So there we go. So that's going to be the distance that our radar will be able to find stuff. Cool. All right. And that means that obviously we'll just remove our ready function. That wasn't very smart. Come on, Bass, learn to type. Pass. Now that does mean that on our collision shape over here, we have our sphere, and we need to make that one local to scene, or else we're going to have one sphere resource, and we can potentially have different radar sizes depending on whether it is our enemy or whether it is our ship or whether it is our missile. So we are going to keep that like that. So that now means that we want to do radar area collision shape dot shape dot radius is radar range. So that's going to set our range that we've configured and apply that onto our radar. Cool. That's all that we want. All right. Cool. So, func gets what's a good name for this? I want to call it overlapping bodies. Get within range. There we go. Okay. So that's our overlapping bodies. Now obviously that's not going to be called that. Overlapping is radar. It's going to be greater area. There we go. And that's now going to be return overlapping. So obviously here we're going to add all our logic that will filter out the ones that actually we want. And here we're going to say gets closest. I'm just going to call it get closest. All right. Closest body, I think we call that. Because now gets within the range. Okay, we're just putting some skeleton code in place because we now need to start copying some stuff over. Okay, so it's going to be a child of our object, so our forward, this should all be the same, so that's all good. So that's all for that one. So I'm not quite sure what we're going to be filtering here, or if we're going to be filtering anything here. So maybe it's a little bit overkill to have that. We'll see. I'm not quite sure about that yet. But hey, we got to start somewhere. Okay. So don't care about any of that right now. But we do care about all of this. Up until here. All right. All right. So close resistance. That one we don't want, because we already have it. There we go. All right. And that's the other one that we need to copy. over here. So we're gonna rename that. Angle. Okay, so this case, actually, because this is going to be a setting, we're going to make that actually start at 45. We're going to make that a normal export variable, and instead we're going to make an onReady var here. Radar angle cos is cos deg to rad radar angle. So that means that it's more readable to what we're doing. And we're probably going to do the same thing in a couple of other places as well. Actually, in this case, we're going to make that 180. Because 180 means that we can see all the way around, which is potentially something that we want to do for this. Okay. Cool. That means over here, we can now do that. Okay. So we're finding our closest within within whatever degrees we have over there. Okay. Cool. Happy about that. So, yeah. All right. So that was our lock angle. All right. So that means that we're going to move this over here. And in this case, we're just going to go our get within range. And this might actually be something that we're going to be making part of our radar logic a little bit more as well. But we'll see. So here we're actually now going to get radar gets closest, because we've got all our logic that we already want to just get our closest buddy, so we don't care about any of that at all. You know what? I actually don't want that to be a So we're going to do the same thing here. I actually want to make that readable, so that's going to be 35. onReady var lock angle cos deg to rad lock angle. So that's going to calculate that. Oops. Equals. All right. I'm actually going to make that a parameter of our get closest. There we go. So instead of this being, I'm going to do it within angle cos. We're going to call it like that. So instead of that being a property, we're actually going to parse that, because that's always going to be a property that's going to be set within whatever we've contained this within. So it's a bit double to have that set as an export variable. So that actually means that we're going to have to fix that up here. There we go. All right. So one thing that we're not doing here, and that's something that I'm thinking about implementing over here, is whether we've got something that obstructs our view. And that might even be something that we would cache, so that if we are asking that same information from the same radar more than once, which we would likely do in our player script, because we are getting it for displaying on our radar, and we're getting it for our finding our closest target when we press target lock. We'll have a look. We'll have to figure that out. Because that could potentially be a very expensive endeavor, because what we will need to do is we'll need to cast a ray from our location where our radar is to the target and see if there's anything obstructing it. Obviously excluding our own. It's going to be very funky to do. We're going to have to figure that one out. But that's not something for tonight. That's going way over what it is that we want to do. So we now have a radar object that is doing all our logic for target locking. We now have our missile doing that. So let's go and do a quick search for $radar. Oh yeah, we need to copy our collision masks through. Almost forgot that. All right. So yeah, so that one we need to implement. Almost forgot that. That's the only place that we're calling that, and that's the only place. So okay, so it's purely a collision mask that we still need to do. And of course I forgot what the notation for that is, so we're just going to have a quick squeeze where we're actually doing that. Is it on the weapons? It might be in the weapon. No, it won't be on the hardpoint. Because I always forget what this is. Hang on, didn't I put it on the add-ons? I think so. Don't know if this one's new enough for that. This one might. Come on. That's still the old one. Okay. I hate it when I forget how these things are working. Come on, give me an example of this. Alright, so don't want to waste too much time on this. We are going to go to open recent. I think I put it in this one. Here we go. Thank you. What we're doing, we are working on our radar. And we need a collision mask. There we go. We want a set collision mask. So that's perfect. Not quite sure where that comma came from. We actually don't care about the default collision mask value in this case. Func set collision mask. Okay. Collision mask is new mask. Again, because this is the first time that we call this, is before we're ready to call this. Oops, that needs to be if. Let's actually do this. Light node. Why does it keep moving? Too many things. No. Put it there. There we go. That gives a little bit less noise in our output, because we're going to get warnings of. We really need to remember to do that more. Collision mask. Okay. Oops. That means that we can add a quick. Oh, we already have a ready function. Very good. Set collision mask. So we just set it to itself, and that's just to then parse it through to our area. Which should now mean that when we look at our missile, we're setting our collision mask, which is going to call our logic, and that's going to be fine. Perfect. Cool. So we don't care about a default collision mask. That's all fine. All right. Let me think. We're setting our collision mask. We got our radar in there. I'm not going to change our plane radar here yet, because I want to see if everything still works. Teach C#. I'm not sure yet. It is something that I do have on my plate that I do want to do at least a tutorial on using C# with the quest. So that's something that I've been wanting to do for a while now. But whether I will do a whole lot in C#, I'm not quite sure, because I don't really see the point for the sort of stuff that I'm doing. Just testing if this is still working. It looks good so far. It is. That is all still working. Very cool. So now we can use our radar or to attempt to use our radar on our plane as well. And then we have one component that we're using in multiple places. So yeah, so C#, you know, it's a beautiful language, but I already use C++ where I need that extra bit of performance, and I just find working with GDScript, because it's so well integrated within the IDE, I just find it much easier. And there really isn't that much benefit unless you do some really, really complex stuff. You know, this project wouldn't be running any faster or any noticeably, or not noticeably faster if we would write all this stuff in C#. There isn't a lot of gain. It's not where the bottlenecks lie. You know, the bottlenecks right now lie in the rendering side of things, and that's all in engine. That's all C++. So that's all a matter of making our assets smarter and making sure that, yeah, making sure that we put our scenes together properly. So, but yeah, maybe at some point. Yeah, so the code on GitHub, again, you know, all my tutorials are on GitHub, so you can always look at those. As far as this project, I am not sure yet because I have problems with sharing it as is. So either I need to upload a broken version that doesn't have any of the assets in there, which means that it's not usable, or I need to find out a way that I can properly put licenses against it. I don't know. We will see. Again, you know, this is one of the reasons why I do these videos. You can see me building most of this stuff, and you can see me code review the stuff that I write off camera. So all the info is there. It's just I haven't found a good way yet to share this code without, you know, without it being a broken application, because I'm not supplying any of the assets. So that's yeah, suggestions are welcome. Let's say it that way. Also, I've been thinking about that sort of stuff to make that maybe even a Patreon thing, that that I give access to the source code of these sort of things. You know, these sort of games that I'm building. So the things that I'm not doing in form of tutorials. I don't know yet. I am still undecided. Okay, so the last thing that we want to do tonight is we want to replace this little guy with our actual radar. Boom. There we go. So that's becoming a new radar. All right, so that's an interesting one. So the question that I have right now is if I change this to actually putting that in there. Here. All right. So I'm actually telling our radar screen to get the closest from there. And I'm not setting that in here, but instead over here we're just gonna say radar dot get closest, and I'm not gonna send a parameter through here yet. So now we can remove all of that. Now we no longer need that, but that means that we're accessing that overlapping bodies twice, and I'm not sure if that's going to have any sort of effect. So here we need to have a is still in there. Okay. All right, we're going to work on that in a minute. First thing that I want to do is in our radar, we have our get closest. Is we're going to give this a default close to that 180. So by default, we're going to make sure that we look all the way around. All right. So, let's see. Ah, really? Okay. So in this case, I will need overlapping is radar. Get within range. Okay. Now the thing that I'm thinking about, instead of doing it like this, is to have some of this logic actually inside of the radar logic, so that we can actually ask it to get the next target. Or same with actually our weapon script, our missile script. That right now we have. Where are you? There you go. So if we are here, we're actually getting our overlapping, and then we're going to check whether that's in there. So I'm thinking about that basic logic that checks whether our target is still within our radar's range, is actually adding that logic to the radar. So that's probably something, two things that I think we can pretty up in this thing. One is adding the logic to select the next target into our radar, and this. And then we can also see if we can do some proper reset logic. So I'm not sure where that's coming from. Oh, that's because we're not using that that get node thing there. So I'll clean it up later. So let's have a quick look and see if our radar screen still works and our selection still works, or whether we broke everything now. Alright, that's still very black. Okay, I think we got a typo here. We have a type nil. So, stop. So I closed. So this is of course always the thing that we have to be careful of, is that somewhere along the line we've lost something. Where was that code that we just hold on, so I run it again because I lost where it's gone wrong. And let it crash. There we go. So update targets on the radar screen. We're gonna get a target list and selected targets, and we're getting null back there. Okay. So that is no, more down. There we go. Oh. Huh? No. Within range. All right, we sent it the wrong one. All right, so that needed to have our overlapping bodies, because that. Huh? What are we doing now? Okay. What did just screw up? It's not wanting to start. We screwed something up. I'm just going to restart this because it's obviously having a bit of a hissy fit. All right. Are you going to work now, or did we really break something? No. I think we didn't stop the debugger properly just now. We're no longer crashing. Very good. Again, we're going to move once the tracking kicks in. There we go. All right, so our radar screen isn't doing anything anymore, and our selections aren't doing anything more. Okay. So you think you're going to do this in 5 seconds, and it takes an hour. Okay. So first of all, I want to get rid of those because obviously, the thing that we forgot is we do need to set collision masks. Now, can I go and pick this back because I want to see what the collision mask should be? Both of those. Okay. Collision mask. Friendly. There we go. Now we should be a bit more lucky. Alright, we've got some dots again, so that's looking good. We got some red dots over there. Cool, let's go in here. That's looking pretty cool. Okay, but our closest logic isn't working yet. Our missiles are still finding locks, so our radar logic does work. But our targeting doesn't. So our closest logic isn't doing what it is supposed to. Okay. So. Alright. So we're not specifying this, so we're going to actually get that to add. You know what? I actually should just put that through as -1. Okay. Bigger than angle class. Okay. Let's see. Should do the same thing, but maybe I just overlooked something. So that's not working. However, the thing that I did wrong is that we aren't filtering just enemies anymore. All right. Well. All right. If we haven't set this, or buddy is house group. No, it's an object, I think. Are groups on objects or are they on the nodes? No, they might be on nodes after all. That's a group. I think it's has group. Is it has group? No, it's not. Is in group. Yeah. Sometimes the auto completion isn't playing nice. Is in group. Is in group. There we go. Cool. And that's because we are doing both here. So when we do our targeting, and again, that means that later on we can actually have a button that we can target through both friendly and enemy targets. Let's handle lock. Okay, that's fine. I want to copy that so that we don't get any spelling errors. -1. There we go. Now we should only find our closest enemy. So now when we select this one, we just get our enemy selected. Very good. Boom. All right. Now I just want to lose my target lock again. There we go. I lost the target lock, so that's still working. Oh, it's still selected. So, okay, now it's on. I just selected one of my friendlies. Okay. Shot that the wrong direction, so it's not going to... There we go. Ooh, that got too late, and that's flying off. Oh. So yeah, they do overshoot quite easily. There we go. We are too close to our targets to do this. Although that should mean that if I do this, and we have target lock, I'm out of missiles. Oh well. Oh, destroyed at least one more enemy ship. There we go. Alright, so that means we now have a nice little radar component. And again, I think what's one of the things that we really need to do here is to put more of this logic inside of our radar so that we just call it from here and can say, well, you know, get the next target, or get the closest friendly, or get the closest enemy, or cycle through just the enemies, so that we can do more with our buttons and be more selective with what we target. And I think that should all be logic that's actually inside the radar. So that also then means that we can call these functions through our AIs, just like we have done with our missiles. There are missiles constantly checking whether it is whether its target is still within the radar. And again, I fully think that, you know, that logic really needs to be inside of our radar logic as well. So instead of calling get within range, we're actually going to call, you know, is target in range or something like that, and do most of this logic inside of there. It just gives a true or false, and then we can simply say if false, then we're just going to remove the target lock. So those are the improvements that, you know, we can do here, and I'll work on some of that the rest of the weekend. But I think as far as we are concerned for tonight, it is almost 1 o'clock. I have a call to do before I go to bed. So I'm going to leave it here. So I hope you guys enjoyed this. We did a lot tonight. Rejigged a few things, improved a few things, got our missiles to be better, got some missile trails. So yeah, been a very productive stream. Again, as always, thank you guys for joining me. I hope you enjoyed it. I hope you learned something. And I really hope to see most of you again next week. So good night, everybody, and until next time.